So, welcome everyone. On behalf of the Mimic Consortium, I would like to invite you all to our final conference today that is held here at Lindholmen Science Park in Gothenburg, but we also have participants online via Zoom. My name is Rodrigo Alfahel. I represent Closer, and I'm also the project manager for Mimic, and I will be your host today. Today we will share the main results and lessons learned from Mimic, and really hope that you find it useful. But before we start, I would just like to go through a few information points. This webinar will be recorded, and the presentations will be available and shared afterwards. Please write down your questions and comments in the chat function if you're using Zoom, but we're also going to use Menti. So for you who are here in the audience, but also at Zoom, you can either download the Menti app or go into menti.com. And we will also soon share the links. And if not, once we have the Menti polls, you will see the right link, so you can go in and answer the questions. And finally, feel free to give us feedback after the conference. And if you would like to contact us, please don't hesitate. This is the agenda for today. This is the first part before lunch. Just very briefly, we will start with me here to welcome you all, and then continue with Anna Fredriksson from Linköping University, Ole Stensberg from FM Byggningsdrift, Mats Jané, Linköping University, and then we'll go for a first poll question and a break. After that, we'll continue with Nicolas Brosseler at the Vrije Universitet Brussels, and Selama Wittmann-Mofufa from SINTEF. We continue with Peter Widhalm from the Austrian Institute of Technology, and Lina Gudmundsson from Elstranden Utveckling, before we take final questions and a lunch. After the lunch, we will start with a short summary of what we have spoken about before the lunch, and then continue with Lars Arnebø from SINTEF, Monica Bilger from Chalmers, Martin Street from Swedish Transport Administration. We'll take another poll question and a break before we head into our final session. That will be with Kristoffer Venås at Oslo Bygg, Anna Fredriksson from Linköping University. We will then have time for your final questions and discussions before we summarize this conference with Kajsa Hultén from Chalmers coming up. For you that are here as well, we will have an extra mingle hour after that. So please feel free to stay and chat with us. Just very briefly before we start with the presentation, what is Mimic about? Very generally speaking, it's about construction logistics. And some of the words you can have with you here today would be stakeholder dialogue, logistic optimization, smart governance, and on and on. It's an EU project with representative, with the core partners being from Austria, Belgium, Norway, and Sweden. And it has been ongoing since 2018. And it's a continuation of a previous project called Civic. Here you can see where the project is funded by. So it's a Horizon 2020 project, JPI Urban Europe. But you can also see it has received funding from each of these national funding agencies. And we're very glad that we had this opportunity to collaborate with each other. And we hope that we can continue like this. And here you can also see the core partners and the LOE partners. Some of them will present today, while others I would like to give an extra thanks to. And it's important that throughout these years, there have been people coming in and contributing. And today you will get a few of them that will present. But I would just like to give an extra thanks for people who has contributed. And I hope I don't forget anyone extra that will not present today. So Koen Momens, Pamela Noltz, Victor Eriksson, Carl Bergström, Caroline Karlsson, and Matti Renthaler. Thank you for being part of this consortium. And yeah, we really hope that we can continue our collaboration. With that being said, it is now time to go into our next point in the agenda. And there will be the urban development and construction logistics that Anna Fredriksson from Linköping University will talk us about. So please, Anna, welcome, and the floor is yours.
Thank you very much. It's a pleasure being here. My name is, as said, Anna Fredriksson. I'm Associate Professor in Urban Development and Logistics, Linköping University, Campus Norrköping. And I've been part of both the Civic and the Mimic project, so it's been almost like a baby to me. So it's a pleasure being here. And we also discussed this yesterday, so I actually had my third child when the Civic project started. And she's 5.5 years now, and very stubborn, but happy. So for those of you who have followed both me and her through these projects, it's been a pleasure working with you. So what's this about? It's about that urban areas are under constant development. And this picture is not representative of how you usually see a city when you see the future urban plans. It's like when it's finished, everything is quiet, there are no tracks, there are no ongoing projects, but there are always ongoing projects and there are always construction traffic taking place. And that's why construction logistics should be a much more central part in urban development and urban planning than what it is today. Because construction transport, 90% of the transports are still on road. And 20% of the transported weight in Sweden is actually construction related. That's rather a lot, a fifth of all the goods transport. And 50% of the urban goods transport weight, seen from a weight perspective, are construction related. And in a construction project, actually 10% of the emissions come from the transports. And this is a bit frustrating, I think, from my point of view, because a lot of focus is put on the materials. And a lot of focus is put on how sustainable the building will be once it's there. But 10% of the emissions during the construction time is actually transports. And we can do a lot. And when we started this project, we had very little knowledge of the construction transport. And during this project, we have collected a lot of data. And we are still in need of very much data. But these actually show some of the transport patterns that we can see in the construction project. And we can see that in average, we have about 0.55, 0.57 transports per square meter in a house building project. But what's really interesting to see here is that about 50% of the transports during the day arrive between 7 and 9. And who is also traveling between 7 and 9 in the day? The rest of the city. So these transports actually disturb a lot. And there is nothing except habit that says that they have to come between 7 and 9. With a little bit of planning, with the help of, for example, checkpoints and so on, which some of my colleagues will come back to, we can actually make a lot of the difference. We can also see that about 43% of the deliveries come with truck. So there is an overuse of truck, I think. There is larger transports than needed for the deliveries. So the Mimic project have had the goals of these three things that we would like to make an impact on. We want to increase the livability and attractiveness of life in a city through decreasing congestion, accidents, noise and vibrations caused by material flows to and from and on site, because we have an impact on the vicinity. We want to decrease the emissions of greenhouse gases, pollutants through improved planning of transports to, from and on construction sites and use of more environmentally friendly machineries and vehicles and alternative modes of transports. 90% of them have to be on road, for example. And we want to improvement and optimization planning of resources, both facilities and personnel, to decrease unnecessary cost and construction delays, as well as decreased impact of surrounding business activities, because we want to keep the city attractive while we are doing the change. And why is this important? Usually when you think of a construction project and construction logistics, you think of one project. But in an urban area, you have this one project. And all the construction transports, they have to go, usually you build in the city center because we are densifying the cities. However, the material suppliers and so on, they are on the outskirts. So all the transports have to go from the outskirts into the city center and back again. So we will have a transport impact much bigger than just the sites. And that's why we usually define it here as in 3 zones. And when you come to a city, it's not just one project, it's always several projects. And then we start getting these cascade effects where the transports actually affect each other, and the congestion and the impact of the construction transports of several projects is multiplied compared to of one project. And that's why you need to take a larger system perspective on construction transports. And why is it a problem to actually control and do something about construction transports? It's because construction projects run as silos. We have before production, we have a lot of planning, but that planning not always include how to handle the during production. And during production, we had the construction logistics, but it's also first seen as a problem once you start. And urban traffic is seen as a problem or something that you have to deal with once you have finished the projects. But we have this constant ongoing projects, so these phases always go into each other, so we should not treat it as silos. And therefore, the overall project goal of the MIMIC project have been to reduce the negative impact of construction sites by improving the governance of construction logistics through implementing smart governance concepts. And my colleagues here will describe more of what it means. But we started with this very hard to read, hard to interpret picture from the Civic. But the thing of this figure is that we show that logistic solutions or logistic setups is something that you have to work on from the very beginning of construction projects. And you also have to involve the main contractor, the developer, and the municipalities, because the construction logistics have an impact outside of the site. It's in the vicinity, but also on the whole traffic system of the city. So this was our starting point, and this we have further developed in the MIMIC project, which have been working then in 6 work packages. The first work package 0 have been project management run by Lindholmen or Closer here, with an excellent project leader here the last years in Roderick. And then work package 1, we have focused on construction logistics scenarios and stakeholder involvement. Work package 2, impact assessments. And work package 3, data analysis and optimization of construction logistics. And we had a very lot of ongoing interplay between these parts. Then we have in the work package 4 tried to gather what we've done in the other work packages into the testing and implementation of smart governance concept, which we then now, as a final part here, try to disseminate. During the project, we also developed a game, for example, 2 types of game, 1 board game and 1 mega game, because we think one of the main issues of construction logistics is that we don't have the knowledge within urban development, urban planning and so on, to handle it. And that's why it's also usually ignored. That's what I wanted to say to start with. I want to hand over again to Roderick.
Thank you, Anna. Thank you for your presentation. And with that, we're going to go on to our next point. I would like to remind you that if you have any questions, you come in. For you online, you can go in on Zoom and already put them into the messages. And for you in the audience, you can of course think about them, and we will have time later to ask Anna and the others. So now it will be time to our next presenter, and that is Ole Stensbjerg from FM Bygningsdrift, and he's going to talk about that construction logistics is more than deliveries. So please, Ole, whenever you're ready, welcome you on stage, and we'll see if it's, I think it's still muted. I think so. Now, here you go.
Thank you. I'm glad to come here and talk a little about my sides from construction logistics and FM management, FM Bygningsdrift, their side on the way they look at construction logistics. One of the things that have been happened the last many years is that we have looked at construction and logistics like it's only deliveries. We try to look from another perspective. FM is a company that has been working with logistics for the last 15 years, 20 years. We are active in both Denmark and Sweden. We make the first delivery system, leveranceskalender, for a construction site in 2006, and just released a new version for 1 year ago. When we look at this, there is a lot of things there is the reason why this is not getting out in the construction site for real. We talked about this for many years, and what we talk about and why it's not functioning is because we're not looking at the most important thing at all. Everyone that's sitting here don't focus on the most important thing. There is only one thing that counts, and this is the guy standing out on the construction site with the hammer and say, what's in it for me? Before we get everyone on the construction site to work with, this is not going to happen. We can have all the ideas we want. We can have all the good plans, everything, but if we don't get it out on the site, then there's nothing happen. So we need to focus on something else. We need to be ready to see, to involve another kind of people in this, and not only this construction logistics have in the last 5-6 years when we have this project been running from mostly the people around this project and some else. I'm so glad to be in Sweden where there's at least someone working with this. In Denmark, no one do that. So I'm so glad to be here in Sweden where someone work with that. But it's not helping we work it here. We need to get it out. And there's only one way to get it out. That's start to demand from the building owners, developers. They have to demand this because there's no reason for Skanska, NCC, PR, whatever, then they don't need to do anything like this because the customer is still coming. Everyone is the same, good or bad level. No one is better than each other and the other one. So there's only one way. If we want this, we need to claim it from the owners and developers. We want this, and we need to show from this group we're working in, there is some effect on this. And money talks. We can talk all we want about environment or whatever, but money talks. And before we can make a system where we can integrate everyone doing the system, this is not going to function. And so this is what we need to do in the future. When we look at the construction site now, we need to see the construction site is construction. That's what we talk about. And when we talk about construction logistics, yeah, where is that? Is it from deliver the materials to the site, or is on site? The last 5 years we only talk about deliver to the site. And in my world, it's the wrong way. We need to see what is in the site and start designing using materials, the fit for the future, the fit for automation, the fit for using more robots, and then we can start optimizing because logistics is also optimizing. So when we only look at delivery, yeah, then it's so easy to call construction logistics. And we're allowed to do that because no one have ever worked with that before. So congratulations, you found a new place because construction logistics has never been used before. So now we talk about it. And today, when we say construction logistics, we mostly talk about people carrying in, and it's not that. Or we talking about the deliverers deliver on time. They always do that. The problem is if they not get the order in time. They're good for delivering. And the material delivers, they have that. Please order in time, then you get in time. So until now, we only focus on delivering and transportation, or putting in the third part and reorganization and we do. But is that construction? No, that's delivery. If we want to have some involvement from the construction business, start talking construction instead of delivery. Then we have a chance to get them. So now we use so much time talking deliveries, and sorry, now we have a lot of data. Now we can show them what we can do, but we're not working with the construction yet, delivery. In the future, if we remember the first picture, this picture, the surrounding areas is the area that get the problem from the construction site. We need to start looking at that also, because everyone that buy apartment for 3, 4, 5, 10 million don't want to live on a construction site. So we need to look at that. So we also need to be aware about how is the future? Is anyone can accept to living on a construction site, or they start going on Facebook, Twitter, Instagram, or whatever, and writing? So that kind of things we're gonna stop so many projects because we get a negative involvement from the societies, the city around us. The status for now, yeah, the last 5 years, I'm sorry, we get a lot of data, but we not move the construction site at all, if I have to look at it. We still do the same mistake. We still do the same thing. One thing we start doing, we used a planning system and delivery system, and there is coming 3, 4, 5 at the market. I'm so sorry, a lot of them is coming from the software companies and not from anyone being on the construction site. So they can everything with the software, but not so much on the construction side. Sorry, I showed the old angry guy. We say we can do a lot for the environment, yeah, but we can do a lot more. So, yeah, you can say we're good, but we're not even starting yet. If we want to make a difference, then we need to start on construction side and logistics. Logistics is not delivery, is not cheap hired labor from Eastern Europe to carry in, or a student to carry in. Logistics is planning and involvement and make sure it's coming on the construction side and not everywhere else. In the future, the surrounding environment gonna claim much more of us. No one wants to be treated like we treat them now. No one wants to, do we want to build or not? We're gonna be here, you can be here. That's not gonna function. That time of aggressment not gonna function anymore. So we need to take care of the environment around us. But do it nice. This is a fine way to show you can do it nice. This is from Carlsberg in Copenhagen, where Carlsberg have planned from the beginning how every site have to run. In Carlsberg we have 26 construction sites at the same time, and someone was talking about checkpoint, and someone was Anna, and we was talking about checkpoint. But in Carlsberg we have 26 construction sites at the same time without checkpoint, only with planning and a system. And it's not because we don't get deliveries, because they get, on the good days, they get more than 500 deliveries per day without a checkpoint, only with planning. And it's not someone else planning it. It's the construction site from the planning. You have to involve the construction site and let the planners on the construction site, the architect and the engineer, be a part of that, and not talking transportation, because transportation, that's function. if we have to do the right thing in the future, when I see it, we need to start when we design the project. So we use the right size of material. We designed a construction site out from the areas we're in. Is it possible to deliver on the road, or we have to build a new road to get in? We have to take care of what have in the whole area, looking from a helicopter perspective all the time. Which involvement do the construction sites have in the area around you? So construction logistics start when the developer have an idea. How do we want to sell this project? What do we want to leave to the area with this project? Because if you treat everyone bad doing the construction site, they're never going to be satisfied with the house. So we need to start much earlier in the project. One more time. What's in it for me? That's the only thing that can move this. And as long there's no one that wants to do anything else that the fast money, so then we're not coming anywhere else in the construction site. Now the logistic is some companies deliver material, where the most focus is delivering materials, call them logistic, or it's company making software, called it logistic, or it's someone carrying in, called it logistic. We need to be more professional and help from the beginning to the end. And it's not about making fast money to carrying in. It's about planning and designing. So when you need to plan the construction logistic, you need to know something about buying materials. You need to know something about designing. You need to know how to make construction. You need to be how to be a site manager. You need to understand the process. You need to know a lot of things about communication with the area around you. You need to, everything we have here is so important. If you don't know that, you can't design construction logistic. If you only know something about cheap labor carrying in or software to optimize that, no software function at all without human. We need to combine the things. The most important thing for whatever we're going to do in construction and logistics is data. If we don't know how much there can, where to put it, how to handle it, then we don't get anywhere. Data is everything, and you don't know that if you only work with software. So from the beginning, designing, production, execution. That's all for me.
Thank you, Ole. And, perhaps if you can stay a little bit longer, we're early on schedule, and we're very glad for that as well. We will take one question from the audience, but please give us a second if you have one. If there are online questions as well, then please feel free to ask them. But do we have a question from the audience here at first? That's just 1 second. I will give you a microphone.
Hello, thanks. Fredrik Cederstad from RISE here. I have a question. If you have looked at the in Stockholm, there's something called MLC, Mass Logistics Center.
Yeah.
You probably know about it.
Yes.
So what is your comment on that? Is some kind of consolidation with masses? And it's been going on for like 10 years. Or
yeah,
years.
There is a lot of good things in that. There is so many good things in that when the project is like in Stockholm, where you can do that. But I think a lot of that we don't need that if we have planned a little better from the construction side. But we still need, when when there's no area at all to be in, you need to think a little different, and this could be a good way to do it. But there's other ways also. But when you have so little area as in Stockholm, you need to have something. But if there have been better planning from the beginning, you could have done with something much smaller. But there's really good ideas in that when you don't have any areas. And but if you at the same time you need to train the construction companies to pack, deliver, and you need to help them to get some new way to deliver and some new way to carry around on the site. And so you use something in and get something out in it. And there's a lot of things you can do. But like that in Stockholm, that's one way to do it. It's not a bad way.
Okay, thanks.
Thank you, Frederick. I will see if we have a question from the online audience. If there is not, please wait. If you have more, we will have more time for it. I will thank you, Ole, for your presentation. And we will go on now with our next point in the agenda. So thank you so much. And with that, I would like to introduce Mats Jané from the Linköping University, and he will present the smart governance concept 2.0. So the smart governance concept that we had for in Civic is now developed, and this is now what Mats will talk us about. So the floor is yours, Mats.
Thank you. And I can hear that my mic is on. That's good. Right, so my name is Mats Jané, as Rodrigo said, and I work at Linköping University. And I want to talk to you about smart governance concept 2.0. But before we get there, we've heard some insights from Anna and from Ole, and this why we are trying to solve what we see as construction logistics within city development. And primarily our viewpoint has been that we have taken this transportation kind of standpoint, because we have seen that a lot of what is actually impacting the surrounding society is the transports. And as Anna mentioned, we have our transports to and from sites between 7 and 9 in the mornings. That's also when I go to our site at the university. But the big problem here is that we of course need these deliveries to come to site, but we don't have an independent construction logistics transport system. That would be beautiful if we could have, but we don't. So we are using the same infrastructure as the rest of society, which means that we are having these conflict situations between construction transports and commuters and urban freight transports and tourists and, well, everyone, basically. So that has been one of our starting points in this. What we have seen during the past 5 or 10 years is that we have started using more and more what we like to call construction logistics setups in terms of big scale terminal solutions, or the checkpoints, or even the planning systems that Ole mentioned, to kind of coordinate and control these deliveries to and from sites. A problem with these, however, is that they quite often contain some conflicting goals. What we have seen in urban development projects is that these are often initiated from the municipal perspective. They have the goal of reducing environmental impact, they have the goal of reducing disturbances for the surrounding society. And there it kind of stops. But we also have the contractors that are building, and they have an interest in having efficient construction projects, making sure that material is there on time when needed, and so forth. And the design of these solutions haven't always taken this perspective into consideration. So what we have done is, in Mimic, we have aimed to develop a smart governance concept for how we can introduce construction logistics early on, how we can design construction logistics setups, and what types of regulations, etc., can be viable to actually reduce the impact on the surrounding society while simultaneously ensuring that we have good and efficient construction projects. But first, a quick retrospective or a trip down memory lane. Anna mentioned her daughter was born during Civic, and I'm not going to talk about her, but I will talk a little bit about Civic. Because in 2018, when we were finishing off the Civic project, we presented the first smart governance concept that Anna already showed you. In this smart governance concept, we kind of started, in a sense, by, this isn't working, here. By taking the construction project's phases into consideration and seeing that, well, we have this planning, we have design, procurement, and production. And we try to fit in where should we design and implement and operationalize a construction logistics setup during the construction phase or the construction process. And we saw that we had different actors impacting the design of this, and we saw that we probably need to know more. So what was actually missing in our view in the Smart Governance Concept 1.0? I was trying to figure this out the other day, and well, firstly, what we didn't have in Smart Governance Concept 1.0 was the view that decisions are taken on different planning levels. So we take decisions regarding construction logistics on a strategic planning level with kind of long planning horizon, but we don't necessarily see it as a construction logistics decision. I will get back to this a bit more. We take some decisions on the tactical level, so the mid-horizon planning level, and of course, we do take construction logistics decisions every day in the operational planning level as well. Secondly, we kind of needed a stronger identification of the different actors' role in these decisions. And in our Smart Governance Concept 2.0, we have seen that these long-term strategic decisions that I said aren't necessarily viewed as construction logistics decisions are often taken on an authority level. It can be things like introducing environmental zones or increasing demands on following up the environmental impact from construction or from the deliveries to the construction sites, etc. We can have it on the tactical level in terms of the program, project, or portfolio actors that may see that, well, we are building, for instance, Stockholm Royal Seaport. We need something to control and coordinate logistics within this area. It can be that one of the larger main contractors have a solution that they will use for a majority of their projects or for a portfolio of their projects within a city, etc. And thirdly, we kind of need an understanding of how to combine different tools and approaches and measures, and things like that. And we did already in Civic come up with some of these tools, but these have been further developed during Mimic. So we need to know how we can gather stakeholder input from different stakeholders. We need to understand how we can simulate and forecast transport volumes, as this will impact both the surrounding society, but also our construction sites. We need to see what types of services we can provide or that we need in urban construction projects. And we also need an understanding for what governance measures and initiatives there are and what could be feasible to introduce to control for construction logistics in cities. And we have been working with these questions for many years now, 3 years in Mimic, so let's stick to that time plan. And what we have seen is that on the authority level, construction logistics is partly approached as a way of reducing environmental impact. And this is in line with all our EU goals, our UN goals of reducing our climate impact, etc. And this is a strong driver for authorities and for cities to kind of start demanding more from construction logistics. We see also that we do have some activities regarding construction logistics planning on all these 3 planning levels, so strategic, tactical, and operational planning. But from the authority level, it's primarily on the strategic level, and the planning on these 3 levels are rarely performed by the same actor or even with the same types of goals. So this leads to a difficult situation. If we want to have a good governance of construction logistics within urban development, we kind of need a holistic perspective on what we are doing. We need to understand what's happening on the construction site, as Ole mentioned, and we need to understand how we can control the deliveries to and from site to reduce impact on the city as well. But we don't really get this holistic approach unless we introduce this as a question on all the different levels. We see that there are many good initiatives and many good tools around Europe. So we have good practices for procuring construction logistics setups, for instance, developing logistics strategies, and also that we need to do some scenario testing before we implement a construction logistics setup. And we will hear more about this later on today as well. It's this holistic, smart approach that we need that we are kind of lacking, though. And that's pretty much where we come in, I hope. And I hope that you will agree as well. Because we have developed Smart Governance 2.0, and this is how it looks. It didn't used to look like this. It's much more beautiful now. But yeah, so what we can see from this is that we can still keep the strategic, tactical, and operational decision levels or planning levels, and we need to keep all these 3 levels. And on the strategic level, that's where we set the scope for what construction logistics should achieve in urban development. Here we have identified authorities, different municipal departments, regional authorities, etc., as key actors that can, through legal frameworks and policies, actually start demanding how we approach construction logistics in a good way. However, in order for us to be able to maybe tweak our policies, changing the legal frameworks might be difficult to do quickly, but in the long term, perhaps we can do that as well. But we need to know what we are going to demand. So we need to have knowledge from different KPIs. We need to measure the impact. We need to understand what different actors need and what they can contribute to in the overall construction logistics kind of vision. On the tactical level, we propose that we work with scenarios for the project, program, and portfolio actors, because this is where we can actually start deciding what type of setup we are going to utilize in a development area or within a portfolio or in a project. And this can then lead to some logistics strategies for that area or for that project or portfolio. But in order for us to actually get these logistic strategies, we need to do the scenario testing, and we can do the scenario testing with the help of forecasting the impact that different scenarios have. We can simulate, we can optimize, we can involve different stakeholders in a stakeholder dialogue through different smart concepts such as the multi-actor, multi-criteria analysis tools. We can here also use games to actually create an awareness between different stakeholders regarding their particular problems with construction logistics. So in that sense, we can at least build a scenario that can work for maybe not all, but at least most of the actors that are affected by construction logistics. These logistic strategies, that is kind of the outcome from this level, then can help us in implementing a final setup by kind of informing our procurement criteria. What are we going to procure in terms of construction logistics setup? Well, that depends on the scenario that we have decided on, which in terms, of course, decides the logistics strategies for that project. So that can feed directly into the procurement criteria that we use to get this setup up and running. And of course, once we have a setup, even if it's a terminal-based solution, if it's a checkpoint, if it's a planning system, we need to evaluate how the logistics is actually working for that project or for the program or development area. And here again, we need to be able to follow up the impact that that construction logistics has on site and surrounding the site as well. So this in its full glory is the Smart Governance Concept 2.0. And throughout the day, we will hear different snippets. We will hear about forecasting, we will hear about impact assessment frameworks, we will hear about games, and we will hear about logistic strategies and even more. So with that, I would like to thank you and leave the word to Roderick again.
Thank you, Mats. Thank you. And before we continue hearing about these topics that Mats mentioned, we will have a short poll question, and we will also then go for a break. So please, before you go on a break, I will introduce you to the question. And as I mentioned before, that I would like you to, if you have the chance, to either use your app, Menti, or go into your web browser, menti.com, and if you can see the code here, we can send it as well on the chat. It's 97478289. And the question is, what are your challenges in construction logistics? And you will be able to submit multiple times, but it's going to be short answers, and you're going to see it in the cloud form taking place here. So we'll see it, but you will have that time during the break as well. So for now, we will now take a break, and we will go back at 11:05, but please be ready, so be here a few minutes before so we can start by then. So with that being said, thank you for being with us for now, and we'll take a short break, and we'll be back at 11:05. I hope you had a good break and that you also had the time to answer the question. As you can see on the screen, there has been some of these questions. We will of course save it for later as well, but as you can see now, the main one that we see is the environmental impact. You also see mentioning of digitalization, that congestion is a challenge, collaboration, I guess collaboration in many different aspects is a challenge, proactive planning, utilization of waterways, and yeah, a lot more. So we will share this with you, and please, if you have more, we can continue this to fill in some of these answers. So thank you for putting in your time, and now it is time for us to go on our next part in the agenda. And now we will talk about the impact assessment framework, both on-site and off-site. And we will start with Nicolas Brosselet from Université Brussels, and then we will Salamavit Mamofufa from Sintef will take over. So please, Nicolas, welcome. The floor is yours.
Thank you, Rodrigue. Thank you. So I'm Nicolas Brosselet. I'm part of the University of Brussels. I'm going to dig deeper together with you in the impact assessment framework we developed within the project. So we really wanted to work around three main pillars. The first is to create a framework that is flexible enough to cope with specific local constraints, while at the same time, create a generic enough framework to allow for comparability across cases and ultimately beyond the project globally. Secondly, also a framework which can accommodate for different scenarios, different setups, while taking into consideration different and relevant KPIs. And thirdly, a framework that also takes into consideration a problem in the construction logistics sector, namely the data availability issue. And so this is the framework that we developed and the final version. First, of course, we have the goal and scope definition, where we define the context. We look at the economic, the construction context. We look at the possible logistics cases which are available in the project, and we look at specific site characteristics which are important in the development of the impact assessment. So we have input from relevant KPIs dependent on the project, but of course to calculate the environmental impact of logistics, we need certain calculation variables. So for example, the transport mode that is used, the transport distance, etc. And then once we have gathered the data, well, we can evaluate certain scenarios, certain setups, and for that we use two distinct methodologies, two complementary methodologies. One is the external cost calculations, and the second one is a life cycle assessment, in which we will go into more detail a bit further on. And then those can be weighted according to certain stakeholder criteria. If certain criteria are more impactful to certain stakeholders, we can then adjust the evaluation to, in the end, have an environmental performance of scenarios. These go from environmental pollution, from climate change or air pollution levels, but also in terms of congestion, in terms of noise, what is the impact on the traffic, on the surrounding community, and in terms of the energy use and the renewable or non-renewable energy use. So two distinct methodologies, as I said, the external cost and the life cycle assessment. I propose that we first start with the external cost calculation methodology. External costs, they come in all kinds of shapes, in all kinds of formats. The most known are climate change, air pollution, but we also think about noise, about congestion, for example. Mainly road transport is responsible for a large share of external cost, and those can all be monetized into what we call the external cost calculator to evaluate different scenarios, comparing different scenarios towards one another. Now in Belgium, we gather our data from what we call onboard units. It's GPS trackers, GPS receivers that are mandatory in all the trucks, the entire territory of Belgium. So we have location data on all the trucks in Belgium, and we have the transported distance. Now, what we then do with this transport data, with the OBUS, is that we developed an algorithm, a filtering algorithm, as to filter from the entire set the vehicles that deliver transports to the site. So we know per day how many trucks are driving, and we can recreate the origin destination pattern, the route that is taken for each truck and its characteristics. And then we process that into a geographical information system environment to detect more information, and then we calculate the external costs that are linked to those transports. And so what we wanted to show you here is really we first tested this algorithm and also the impact framework on one pilot site mainly the one that is located in Anderlecht in the Brussels capital region. And like Anna mentioned before, it has a huge impact, not only on the construction zone itself and its immediate surroundings, but also on the highway, on the ring, and on the highway infrastructure, but also the road network along the canal region. So that is the canal that crosses from south to north or north to south the capital. But also, it has an impact on the traffic system as a whole throughout the city. And now we are checking if it's possible to extrapolate those findings and extrapolate that algorithm, use that algorithm for 83 large construction sites in the Brussels capital region to see what is the impact on the entire city of large construction sites. Now, if we look at the total external costs and kilometers driven per month, we see that here, so in this graph, we have the columns that represent the total external costs, so per month, in red for the Brussels capital region and in yellow outside the capital. And the spark lines are the same, but in vehicle kilometers. So in red, the kilometers driven in the capital, and in yellow outside, and the green is then the total kilometers driven for that construction site in total in absolute figures. And what we see is that it really correlates logically as well with the construction phases of the site. So we see that, for example, in April and in May, we have a subnormal production because of lockdown, because of foreign workers that need to quarantine. We have the construction holidays, which are typical and simultaneous holidays in the Netherlands and in Belgium in July, way lower deliveries there. And we see also 3 big months in March, in June, and in September, where we have a lot of concrete and steel deliveries. And especially for September, we see a very nice transition between the superstructure of the building and the ceiling of the building to different construction phases from August to September, where we have a lot of material deliveries for insulation, for windows, etc. Now, this is one construction site in the Brussels capital region, but what if we can deduct the influence of the construction holidays on all the trucks in Belgium? Well, we have, like I mentioned, we have simultaneous holidays. It's a 3-week period in which the construction sector is totally inactive in the month of July in the Netherlands and in Belgium. So we can deduct the construction-related traffic from total traffic when we compare it to a reference period outside of the construction holidays. And we see that that difference is approximately 17.5%. So we know that that 17.5% of total traffic is related to construction-related transport. We will not dig too much into detail, but this is a breakdown of the construction logistics fleet, where we see that most of the trucks that are being engaged are higher than 30 ton in maximum mass. And that most of these trucks and most of the kilometers that they drive are done with a Euro 5 or a Euro 6 engine. The counter side of the medal, of course, is that we still see that more than 40% drives on older Euro standards, hence also having a higher impact in terms of air pollution across the territory of Belgium. Here, important to note is that the construction transport are said to represent more than 15% of total external costs, which is, of course, a large share in total traffic. And this mainly comes forward due to congestion costs, but also infrastructure, climate change, and still air pollution costs. And then, I don't know how much time I still have, more or less, but this was a final case. It's from the Brussels Construction Consolidation Center, in which we analyzed 2 scenarios. Okay, what would happen if we implement a BCCC, which was the actual case, compared to the business as usual, in which we deliver all the transport from the suppliers, from those 4 main suppliers across Belgium, to immediately the construction site. And the conclusion was there that thanks to the implementation of the BCCC setup, we have a reduction of 59% of total external costs, mainly again from congestion, because we take a lot of trucks off the road that are not driving on the highways in Belgium, and a large reduction in climate change costs. And with that, I would like to leave the floor to Selena.
Thank you. Yeah. Can you hear me? Yes. My name is Salamavik. I'm a senior researcher at SINTEF in Norway. I will talk about the life cycle assessment part. As Anna mentioned earlier, the construction site, they have significant environmental impact, representing around 10% of the emission, and in Norway, around 25% of the waste is from the construction activities. And there are a lot of ongoing activities on emission-free and fossil-free construction sites, but the increasing the efficiency of the construction and supply process will also contribute significantly in this emission reduction. And there is also huge potential in decreasing air pollution, create safe working place, and also achieving environmental goals. So as Nicola mentioned, we developed the impact assessment framework with a MIMIC project, and using the two methods. I will talk about LSA we use for environmental impact assessment of construction logistic activities. So we use the case study, the demonstration pilot, the Oslo emergency ward. This is under construction, expected to be finalized in 2023. And there are different construction logistic solutions considered in this project, including the use of fossil-free and emission-free solutions. So for our evaluation, we follow the LCA principles, define the goal and scope of the work, collect data, perform impact assessment, and interpret the results. So the goal for our demonstration pilot is to evaluate the environmental impact from on-site and off-site construction logistic activities. And we include the transport of mass and materials to and from the construction site, the construction machinery, and on-site construction activities, including internal transport, energy use, and waste, and also the transport of waste and waste treatment. For the life cycle assessment, we use the life cycle modular principle, and we include the two life cycle modules, A4, which is the transport from the buildings to the building site, and A5, the construction activities. And there are two indicators we have used, greenhouse gas emission and resource use, both renewable energy and non-renewable energy. So as we have collected data for the activities shown on the right side, based on actual data from the demonstration pilot. Since this is ongoing project, we have collected only from the groundwork and foundation and superstructure construction phase, and we have used generic background data for the evaluation. This is an example of how we have evaluated the construction machinery, including the impact from production of machinery, energy use of the machinery, and also the transport of the machinery to the construction site. To see the impact from emission-free, fossil-free solutions based on the base case scenario or what they have considered in the project, we have conducted scenario analysis for the machinery and mass transport. And also we try to consider the impact of model shift for the material transport. So by combining this, based on the data we have collected for the physical activities and also the scenarios, we have conducted the impact. And this is the result for the emission part. And the top figure shows the total greenhouse gas emission in ton CO2 equivalent for the activities given in the x-axis. And then the figure below shows that the emission per meter square per year in kilograms CO2 equivalent for the activities. So as you can see, the mass transport is the main contributor, followed by material transport and machinery, which represented most of the emission. And when it comes to renewable and non-renewable energy, the mass transport and the material transport contribute mainly for non-renewable energy, and then the machinery, because of the use of more biofuel and energy use, the impact from the machinery is more from renewable energy consumption. This is the result per life cycle phase. So the impact from mass and material transport, which is before life cycle stage, represents 60 to 80% of the impact, while the construction or the installation process A5 represents the remaining part. For the scenario evaluation part, since mass transport is the main emission contributor, we try to consider these scenarios as I mentioned earlier. So if 100% diesel was used, there will be 40% more impact from the mass transport compared to the base case scenario. But if all the vehicles be electric driven vehicles, then the impact should have been reduced by more than 80%. So this is very significant. When it comes to the modal shift for the material transport, because there have been around 10% of the transport used by boats, but if all the materials were transported by road, then the impact would have been increased by more than 15%, while the impact would have been reduced if by more than 70% if different modal means of transport have been used. So this shows there is a potential for electrification in achieving emission-free construction logistics, but the focus shouldn't be only on site. That's the current situation in Norway. But we need to focus also on electrification of the off-site construction logistic activities. But when conducting LCA, it's very time-consuming and it's difficult to find data. And the result is also affected by the quality of the inventory and the background data. This is an example of how the reference values vary based on different resources. For comparison for electricity, biodiesel, and diesel. And even some of the reference there is missing values. So it's difficult to use this reference. In conclusion, there is a large potential in electrification of both on-site and off-site activities in order to achieve emission-free construction logistics. But it's important also to consider other construction logistics solution, which has been presented earlier as well. And implementation of the impact assessment framework in smart governance concept, Mats presented, will help to evaluate and follow up actual impact strategies like the requirements set in the procurement. And LCA and ECC methods need to be conducted in the early phase in order to evaluate, plan, and compare different emission reduction measures, but also during the construction phase in order to see the actual impact reduction for measures. But there is also a need for clear description of the system boundary, assumption, and the background data source in order to make really good comparison or to understand the result. Finally, including the whole life cycle, not only the construction phase, but the whole life cycle is important, and also including more indicators. For example, in Norway, we are focusing on greenhouse gas emission, but we need to include air pollution and others like Nicholas presented earlier. As a further work, we also saw in the question, digitalization is important for both data collection and also for life cycle inventory database. and collaboration, as Rodrigo said, in different forms is important to increase accessibility of data and also availability of solutions, and more best practice and reference values, and finally methods which shows the environmental impact reduction measures, the actual impact on achieving environmental goals is very important. Thank you for your attention. If you have any question related to LC, you can contact me or Christopher, or questions related to ECC, then you can contact Rodrigo or his colleague. Thank you.
Thank you, Nicola and Salam. And we will, before we move on to our next point here in the schedule, I would just like to point out that you can ask, well, if you're online, and start asking now, if you either use Menti or Zoom, and we will have time later to answer these questions. So please, if you have any questions, you can start putting them in here. And for you sitting here, of course, think about your questions, and we will take some of them very soon. But now it's time to move on and to introduce our next presenter. It's Peter Widholm from the Austrian Institute of Technology, and he will present about the impact of construction logistics on city traffic. So over to you, Peter.
Now it's on. So thank you again for the kind introduction. So I'll just switch my slides. So my name is Peter Widholm. I'm a data scientist at the Austrian Institute of Technology, and I will talk about ways and methods to evaluate and analyze the impact of construction logistics on city traffic. In the MIMIC project, we developed and applied methods to observe and methods to predict this impact. We can observe city traffic by analyzing mobile phone data and by comparing the situation before, during, and after construction works. We can assess the impact of a construction site that already exists. But of course, for construction logistics optimization and planning, we need to evaluate different scenarios before they are implemented. And for this, we developed a multi-agent traffic simulation model based on the Maxim framework. And in my talk, I will talk about both of these methods. We applied the methods to the test site in Vienna, where currently a new subway line is being built. This is a quite large construction project, and it involves several construction sites throughout the city. And one construction site was at an intersection with an existing subway line in July 2019. And because of this construction site, a section of the existing subway line had to be closed, and car traffic has also been affected as several of the driving lanes were closed as well. So how can we use mobile phone data to evaluate and measure the impact of such a construction site? Mobile phone data do not contain precise GPS coordinates, and neither are they sampled at regular time intervals. But instead, only when mobile phone or any other mobile device communicates with the cellular network, a record is generated. And this record only contains the ID of the antenna through which the device communicates and a timestamp. So when you look at this example here on the right side, let's assume that a mobile phone is used for a voice call, for example, at this location that is marked by the red dot. Then this device will not reveal its precise location. but only the ID of the cell. So it could actually be anywhere within the coverage area of this cell. This is all that we know, plus the timestamp, of course. Also, the mobile phone data are always anonymized, and they are rehashed every 24 hours. And this means that a randomly generated numeric ID is changed every 24 hours, so that it is not possible to relate the different records of the same device for a period longer than 1 day. When we look at the sequence of mobile phone records generated by one device, then we can observe how it moves and travels through the city. But as I already said, the spatial resolution is low, and also the gaps between the records can be quite large. But the advantage of mobile phone data is that they provide information about a large sample of the total population, and also they are always up to date as compared to travel survey data, for example. So I think we could say that mobile phone data are actually not really suitable to observe the precise movements of an individual, but they provide statistics about the movement patterns of the population. But for this to work, we need probabilistic techniques. And in our case, we developed a probabilistic method to infer from the mobile phone records the travel route. We do this by matching the mobile phone data with the transportation network, both the road network and the public transport lines. And this matching is not only based on spatial proximity, but it also takes into account temporal aspects, such as, for example, travel times between 2 points or the public transport timetables. And this matching is probabilistic in the sense that there will not always be one unique travel route matching the records that we can observe, but there could be several of these matching travel routes. And our method will compute the most likely routes along with their respective probability. And in the next step, we can aggregate all of these reconstructed travel routes and translate them into traffic flow volumes on every link in the transportation network. And on this picture, you see the result of the traffic flow volumes computed only from the mobile phone data. So there was no extrapolation or calibration involved. This is just what you get directly from the mobile phone data. The green lines here represent the subway network in Vienna. The blue lines are trains, red lines are trams and light rails, and black lines are the roads, the road network, and the thickness of the lines represent the transport volumes. And what we see here is the situation in March 2019, which was before the construction work started. And if we, and here you see the location of the construction site that we investigated, and the section of the subway line that had to be closed due to the construction work. And if we now look at the situation in July of the same year, in 2019, then we see that traffic volumes change significantly in this area of the construction work, but also in the surrounding areas. You can immediately see this from the mobile phone data. And maybe we can see it even better in this map, where we plotted the difference in transport volumes between the situation before and during the construction work. And here red indicates increased traffic volumes and blue indicates reduced volumes. And we see that in the area of the construction site, of course, the traffic volume along the closed subway line drop significantly, but not only there, but also in the areas before and after the construction site. And this strong but thin red line is a rail replacement service that was put there during the construction work. And we could observe that some of the passengers actually switched to the rail replacement service, but actually it was only a small fraction of the passengers. Most of them used another subway line that ran in parallel a bit to the north. And we can see this by the red color there. Of course, we can also look at the impact on car traffic. So this would be the differences of traffic volumes that we can observe in the road network. And again, we see decreased traffic volumes in the area of the construction site. And also we see slightly increased traffic volumes in some other areas up, yeah, a little bit further up to the north and east. But we have to remember that this was during July. And this is the area where two of the largest outdoor recreation areas in Vienna are located. So this could, at least in part, be explained by just people traveling to and from these recreation areas. Okay, so far I have talked about mobile phone data and about observing traffic and observing impact. But of course, for planning and optimization, we need to evaluate different scenarios. And for this, we developed a traffic simulation model. This model included Vienna plus surroundings in a 30-kilometer radius. It included the entire transportation network, again, both roads and public transport, and also a large number of facilities to visit. And the model was informed by different input data sources, for example, Travis surveys to calibrate mode choice models, for example, and also traffic count data collected at 180 different count stations in Vienna to calibrate transport volumes. And actually, you can also use the mobile phone data to inform the model, and this would then mainly be trip chains that define how the simulated agents in the simulation move. By the way, this model has already been published. It's publicly available on GitHub under this URL you see here. So it's github.com/aitenergy/MaximModelVienna. And yeah, everybody can download it from there and use it. So when we want to use the simulation model for optimization, then we can define, optimization can define different scenarios we want to test. A very simple example would be that the scenario says that only one driving lane can be kept open in some area, but of course the scenario would include more information, such as how construction material is delivered and where it is stored and so on. And we can then use the simulation model to predict changes in route choice, for example, and the resulting transport volumes in the network again. This time for 3 different construction sites in Vienna. And in this case, we see forecasts and not observations. So that's a difference to what we have seen before in connection with the mobile phone data analysis. And of course, the simulation model can also tell us about congestions and how travel times change, and visualize the differences again in the transportation network. And this output can then be used to further optimize construction logistics. Okay, just to wrap it up quickly, I told you that mobile phone data can be used to measure and analyze the impact of construction works on the city traffic when they already exist by comparing situations before and after, before and during. And the traffic simulation model can be used to evaluate different scenarios before they're implemented, and they then provide the basis for construction logistics optimization. Thank you.
Thank you, Peter. And please, if I can have the click. Thank you. You will have the time to give your questions to Peter very soon, but first we have one more presentation before we go to questions and then lunch. And with that, I would like to introduce Lina Gudmundsson from Älvstranden Utveckling, and she will present the strategy for building logistics in the river city here in Gothenburg. So Lina, whenever you're ready, the floor is yours.
All right, thank you. All right, thanks for having me. My name is Lina Gudmundsson, and I work at Älvstranden Utveckling, which is a part of Gothenburg City. I think I will start off by saying I am not an expert on construction logistics at all. That's not my field. Unlike all of you rest that are presenting here today that are the real experts, but I work as a project leader for one of the urban development projects here in Gothenburg along the river. I'm an urban planner, and I was sitting here listening to all of these talks, and I'm thinking, well, I don't need a PhD in building logistics to see that we are going to have big problems here in Gothenburg developing our areas on time, at cost, and with the quality of people living in the areas surrounding these big building sites, because they will be ongoing for a long time. So I will talk a little bit about that challenge and what we have done as part of Mimic at Älvstranden. So basically, here you see a picture of Gothenburg, and this is Scandinavia's largest urban development project right now. So central Gothenburg will double in size. Some 25,000 new homes will be built, 50,000 new workspaces. And all of this is downtown Gothenburg in the old shipbuilding areas. And that land is now being turned into urban residential areas and office areas. And that's what we work with. And we have, so all of our projects are sitting along the river, so we always have this big barrier that we have to work with. And so the whole project started about 10 years ago now, and I'm working on the part that is called Södra Älvstranden, which is basically across the river from where we are now located at Lindholmen. And besides all of these projects, Gothenburg is also right now having huge infrastructure projects. There's many new bridges across the river and tunnels under the river being planned for and being built and completed, a tunnel under for trains and so on. So there's big infrastructure projects at the same time that we are trying to turn all of this into new urban sustainable neighborhoods. And so at Älvstranden, we saw that, well, we're going to need to start to think about construction logistics and what is our part in this? How can we be trying to push the development further in this area? And so as part of Mimic, we have developed a strategy for what we can do in our part of this big project in Gothenburg. So this strategy was completed in March this year. And I think the strategy in and of itself is not presenting anything that is revolutionary in any way that will drastically change how we do it. But by having a strategy, we initiated something, and now we are talking a lot more to the other parts of the city and how are we going to do this together. what are our different roles and what sort of demands can we have on the developers that are the construction companies that are building and so on. So it's been interesting being the project leader for this strategy that we now have in place. And just very, very short about the strategy, it sets out two main objectives. So it's saying that we need to improve construction logistics in all of our projects. So from our perspective, it has to be attractive to live in these areas at the same time that there is an ongoing construction sites. I mean, if you move into one of the first completed blocks, you will have construction sites around you for the next 20 years maybe. So it has to be attractive, accessible, mobility and all of these things. And we also say that through improved logistics, we can lower the carbon dioxide emissions. So our goal is to reduce them by 50% by 2025. And when we calculated and looked at it, we are saying that by improving the construction logistics, we can contribute to that goal by maybe up to 5% out of those 50%. So from now on, all of our projects has to very early on start to deal with how are we going to do this whole thing around the logistics, and we have to start that much earlier than we have up until this point. So the strategy consists of some general recommendations that now on will apply to all projects, and then we have a chapter that looks at ideas to explore where we think that we can kind of push the envelope a bit and become better at this. There is also some guidance how to analyze your project and to make sure that you prioritize what is most important for your specific projects, because all of the projects are obviously different and have different challenges and so on. And then there's one quite important chapter, which is the different tools that we as a landowner can use. So basically, when we do the allocation of the land to the different developers, we can very early on set demands and requirements saying that if you're going to have this land along the river here, you need to be part of this solution together with the others, or you're going to have to use the river and so on. So we can be much sharper earlier on if we know the challenges ahead and how to what we think could be a way to go. And then there are some strategic choices to be made early on in each project. And so then, parallel to developing the strategy, we also did a pilot project within the River City, which is trying to test the waterways, saying that as long as we don't use the river, it will only be a barrier to all of our projects with very few access points. But if we start to use the river, we turn it from being a barrier into something very useful. And so here we were trying to use the waterways, bringing in, you see these homes in the little folder there. So it's modular homes that are being made in Lithuania. And so they go from Lithuania by boat to the south of Sweden, and then they go by lorries from the south of Sweden up to Gothenburg. And they are being put here on this pier in Frihamnen, and they're going to be there for about 15 years. So it's temporary homes. We're using this area because there is a very urgent housing shortage in Gothenburg right now. So for the next 15 years, we can use this area. And so there's going to be almost 1,000 homes there. Right now, I think there's about 400. So they're continuing now to arrive. So this project we did about a year ago. And so we said to the company that are bringing these modular homes up and putting them here that we want you to try to bring them in by the river. You don't have to unload in south of Sweden, try to go up the whole way to Gothenburg and do it that way. And so that was a pilot that we did. And here are just some photos of what that looked like. So this flatboat, I think it's called, that you see have arrived here, and they are unloading one home at a time, putting them on a lorry, and then the last 100 meters, they had to go by lorry to the site. And there were some very interesting lessons learned from this project. So basically, we saw with that, one flatboat could bring in 48 units instead of 24 lorries taking 2 units at a time. We saw a huge reduction in the carbon dioxide emissions, 60%, that's quite a lot, compared to if they had been brought in by the road. And then also there was some good savings in when it comes to efficiency. So basically they could unload all of the units in one go rather than unloading 4 units at a day over a 12-day period. And there was also no need for special transport permissions in order to bring up a wide cargo on your lorry. Obviously, there were other sort of permissions that you needed to bring in the boat and to access that. But we saw that this is successful, and we need to now be much sharper in actually using the river and putting that as a demand early on in the project, because here we were kind of saying halfway through, actually, could you try using the river now? And that caused them some problem, because they had obviously their schedules and so on. So that took some, we had to persuade them to do that. But we saw that this is interesting and we need to do that much more. So we actually have initiated now another project within the River City project to see whether we can do this in all of our areas, because it is going to be complicated delivering all of these projects on time. Right, so I think that was all about that strategy that we now have in place. And I'd like to say thank you for being a part of this project, because for someone that don't know much about logistic issues, it has been very useful to be part of this in order to do this sort of work. Thank you.
Thank you, Lina. And please, if you can still stay here, because now it's time to get some of your questions. And I would also ask all the presenters before to just go up on stage. And if the question, if you feel you would like to answer it, then please come closer so they also can see you online. But please, if you can go up on stage, and we're going to have a microphone for you ready. I will also switch, because we see we have few questions as well online. So we will start with the first one online, and if you have anything here from the audience, then we will take it afterwards. So to Nicola, could you please step forward? I will read it for you as well, and you will see it here. No, sorry, we will have this microphone, Nicola, so you don't need to. Okay. So the question is, what does the BCCC work, and how did you model the impact of implementing the BCCC on truck traffic in Brussels?
So what we did is that we compared 2 different scenarios. So one scenario was using the inland waterway as a main mode of transport. So we see that from 4 different suppliers across Belgium, they delivered all the materials to the heart of Brussels, to the BCCC, which was located at the port of Brussels. And we compared that to a scenario where all the trucks delivered materials straight from the supplier with the traditional method using heavy-duty trucks to the construction site immediately. On top of the BCCC scenario, we also, so the BCCC was also there to consolidate the materials to a maximum. And so we had the last mile, the last kilometer. So it was actually an average of 10 kilometers back and forth from the BCCC to the construction site across Brussels. That was optimized using heavy goods vehicles. I don't know if that really answers the question.
If that's the case, then they can please comment, and we will get back to you as well. So thank you, Nicola, and we'll go on to the next question. If there are any from the audience here, then please feel free to raise your hand and we'll give you a microphone.
Thank you. I'm Björn Söderdahl, and I would like to thank all the presenters for very interesting presentations. And I have a lot of questions, but I perhaps start with a few of them. And the smart approach, you have mentioned the strategic, the three levels. And of course, one of the interesting points here is in order to get the coordination that is needed, you need to involve the municipalities and somehow get them early involved. And their role in this is, of course, one interesting part. Can you say how? Can you say something about how this is being implemented? Are there good examples that can be used? And can you say something concrete about how you're getting the municipalities involved and their role established in order to make this work? Because that, I guess that's the only actor who can actually make this happen at the highest level. If you can comment on that. Thank you.
Thank you for the question. Anyone would like to answer, then please come on over here so they can see you.
Yeah, thank you, Björn, for a very relevant question. And implementation is an issue, I would say. And why it's an issue is because the lack of understanding and knowledge about the impact of construction logistics among the municipalities. However, Lars Arne, who's going to present about the legal frameworks this afternoon, is also going to give a bit of overview on the impact or the level of implementation through policies and legal frameworks on the different levels in Sweden, Norway, and Belgium. However, what we are trying to do is to communicate with the municipalities. We have the Swedish Traffic Administration part of this project. We also have the city of Stockholm and also work tightly with the city of Gothenburg, mainly through Älvstranden here, but in all other projects we work very tightly with them as well. And my feeling is that when we started the Mimic project 3 years ago, then we had very little response from the municipalities. The main message was, it's not our problem, it's the main contractor's problem of construction logistics. However, today I would say we raise interest, we get the municipalities and the public developers take part in projects, they also take part in our presentations and so on. So I think change have started to happen. We also have this in Sweden legislation of that you have to show the transport impact of the 3 largest materials when you present the environmental impact of a building. And the more data we collect about the logistics impact, the more we can also show that it's something that we have to consider.
Thank you, Anna. Would someone else like to shortly comment? Or we move on to the next question? And that I will take one online. You can see it here already. It's for Peter. And the question would be, would it be possible to replicate results for the city of Brussels giving MSP population densities with a developed SIM model? So, please, Peter.
Yeah, thank you for the question. Okay, hope you can hear me now. Yeah, thank you for the question. You could use the same simulation framework and the same approach, but not the same model, because this would involve building the model, including population synthesis and the agent behavior and the transportation network and so on. And the simulation model that we built is only valid for Vienna. But of course, you can follow the same approach and build your own simulation model for any other city.
Thank you, Peter. Do we have one more question from the audience?
Hey, Kristina from Volvo here. I'm quite interested in this LCA and EEC, the cost there, because I can see that from entrepreneur side, it's even though if you would like to be very fossil free, you can today buy trucks, electric trucks, but the cost is quite high today. So would it be possible to combine those methods and give some more positive figures maybe for those entrepreneurs thinking of buying electric trucks? Thank you.
Very good question, because that's our plan to combine the LCA and ECC method in order to evaluate all these emission or fossil-free solutions in terms of the cost. That Nicolas is expert in the ECC part, so he can more explain about the method.
Thank you. So the external costs really has a broader scope in terms of indicators that we analyze. So so we analyze the impact in terms of CO2, in terms of greenhouse gas emissions, but also in terms of air pollution, for example. Also in terms of congestion, in terms of noise, so on the general traffic, or the impact that it has on the entire environment. But that is only on the transport usage part. That is only on the usage of the vehicle itself. While the life cycle assessment it focuses more on the environmental aspect, but has a way broader scope, because it also includes the beginning of life, so the production of the vehicle, for example, and the end of life activities. Now, in terms of zero emission, yeah, we need both methodologies to really create an overall idea, idea of the total impact that construction logistics has. Yeah, your specific question was on zero emission, I think. In Brussels, at least, we are far from being at zero emission. Those are simulations that we can run, but zero emission vehicles, especially trucks, are not for tomorrow. We did run some simulations on, for example, a diesel ban in Brussels and the impact that it would have on traffic. And there, the results show that, yeah, because the market is not ready for with electrical vehicles and electrical heavy-duty trucks that are mostly used in construction, well, those are replaced with electrical smaller vehicles, which then lead to more vehicle kilometers in the city, and then we see a huge impact in terms of congestion and in terms of the impact that it has on the overall road transport network.
Thank you, Nicola. Just to announce, I think we have a little bit problem with the camera for you online, but we're working on it, and hopefully it will work very soon. Sorry that we have a bit of delay, but we have one more question, so we'll take it quite fast and see if we can have a fast question as well. And Lina, it's for you, and you can see it here. I will read it as well. Can you enforce transport mode choices to contractors, LSP, as from the procurement process, e.g., X% needs to be transported through water, minimum requires on zero emission transport, etc.?
Thank you. That's a good question. And I think the answer is no, we can't really force, but as the landowner, we can make it easy for them to use the river by saying, here is areas where you can come in with a boat, and we will build a sort of common logistics center at a strategic point. So we can make it easy and then say, this is what we propose that you will use. And Elfstenden has worked in a similar way with sustainability and other type of questions for a long time, where we early on team up with all the developers that gets the land allocations, and we say we set up some common rules for how we're going to do this area together very early on, and that has worked very well. So I think that we can use the same model for handling this sort of question now, but it's hard to force in that sense. Thank you.
Thank you, Lina. Thank you. So with that, we are now going to lunch. Sorry for the small delay. We will then continue afterwards with our next points on the agenda. But for you who are here, please feel free. We have a lunch waiting for you outside. And for the others who are online, we will now take a break, and we will be with you at 1 o'clock again. So have a good lunch, and we'll see you again. Yes, I will take it again so you can hear me. Welcome back, everyone. I hope you had a good lunch. And we will now go on and move on to our next session. And with me now, I will introduce again Mats Janér from Linköping University, and he's gonna very briefly summarize what we have spoke about before, and also talk about what we're gonna do in this next session. So please, Mats, take over.
Thank you. Okay, as you know, I love this image, if I can get it here. Yeah. And of course, I want to kind of have this as my general background when introducing what we have been talking about. We started out this morning hearing about the challenges that we are trying to kind of solve, or at least give our input on how to solve. So Anna Fredriksson and Ole Stensberg spoke about the challenges that we are facing with construction logistics, both from the kind of mimic project perspective, but also from the more practitioner perspective from Ole. And what we can definitely take with us from there, I think, is that we need to focus not only on the transport, but also what's happening on the site and in the surrounding areas. And as part of that, we have developed this wonderful framework, and I spoke at length about that, and I will not speak more about it now. But we saw some of the very useful tools that we can actually connect to this framework in terms of the impact assessment frameworks presented by Nicholas and Selamawit, and also the simulation and usage of mobile phone data that Peter spoke about. And finally, we got to hear about the logistics strategies from Älvstranden, which, at least for me, what I bring with me from that is that it's really nice to see a large municipal development company starting to take control of this issue. Moving forwards for the rest of the day, we will keep going into details on more detailed level than this wonderful image. And we will hear about legal frameworks and policies. We will get an introduction to the two games that have been developed during Mimic. I'm also missing something else. We will hear more about the need for data, and we will hear from Omsorgsbygg in Oslo about their experiences with construction logistics and the Mimic project. And finally, I think Anna will come back and kind of wrap up and show us the challenges ahead, followed by Kaisa, who will summarize the entire day. With that, I give the word back to Roderick.
Thank you, Mats. And we will now move on to our next speaker in the agenda. I will give Lars-Arne just time to put up his camera on and also the sound, because he's going to be our first presenter who's going to present online. I will soon stop sharing my screen as well. I would just like to mention, because we've shown some of the things before, and we will have it already at Mimic website, so please, you will be able to read more about them and the deliveries we had, and we will also send a link for you on Zoom. So in case you are not able to follow now, you will be able to read more about them in detail as well. So with that, I will stop sharing my screen, and Lars-Arne, I can see that you're with us, and please just briefly, if you would like to try your sound as well to see if we can hear you.
Yes, can you hear me?
We hear you very well, and now I ask you to share your screen and presentation. Great, we can see your presentation, and now we can see it in full screen. So over to Lars-Arne from Sintef, and he's going to talk about the legal framework. So with that, over to you, Lars-Arne.
Thank you, Rodrigo, for inviting me to this exciting conference. I'm sorry that I was not able to join you in Gothenburg, but I hope it works well out to hold my presentation online. My name is Lars-Arne Bø, and I'm a geographer and an urban planner, and I work as a researcher at Sintef. I have to say I'm not an expert on transport logistics, but I have worked a lot with legalization questions in zero emissions neighborhoods where transport and logistics is very important. Okay, why is I have this screen showing in the top here. I think I will try to share one more time.
Yes, please try that. Yes, we can now see your screen again.
Yes, but I cannot see my headlights, but that's okay. Okay, why is policy framework important? Policy framework is very important to reduce negative impact of construction sites and surrounding community. A review of the Planning and Building Act and the Building Code in Norway shows no specific requirements related to fossil-free or emission-free construction sites. And that can make it difficult for the municipalities to reach their goals. By legal framework, we refer to absolute requirements that must be followed in all planning decisions at all three governmental levels. By political framework, we mean guidelines that all planning must follow, but that do not necessarily have absolute requirements, but rather overreaching goals. This is a part work package 4.3 in MIMIC, and the objectives of the study is to design policy and legal framework requirements which support the implementation of the smart governance concept of construction logistics, and to give an overview of the legal and political status at the strategical, tactical, and operational levels from Norway, Sweden, and Belgium. I will mostly talk about Norway, but also a little about Sweden and Belgium. And I have had very good help from Anna and Mats on the Swedish part, and from Nicholas on the Belgium part. The content is to find out the existing legal frameworks in Norway, Sweden, and Belgium at the state level, regional level, and local level. Acts and guidelines at different public administration levels. And we had also looked at some good examples from logistic perspective from each country. And finally, the most important recommendations for approaches to create awareness and have an impact on legal and policy development. In all three countries, political movements towards more green solution opens for implementation of construction logistic solutions demonstrated in the MIMIC project. There are several activities to achieve higher ambition levels in regional and local requirements for construction sites, including transport and construction logistics activities. From a logistic perspective, the legal framework in Norway at the state level can achieve a much higher ambitions when working at the state of the regional, county, and local as a municipal requirement for transport and logistic associated with the construction sites. We have done an overview of legal and political framework at all three countries, and we have looked at it at the strategic, tactical, and operational level. This is from the Norway's side, and if you look at the state level, it's of course at the strategic side, it's important with the acts and the building codes. And both at tactical and operational side, the ministries and directorates work towards counties, municipality, and partly actors and stakeholders. If you go down to the local level, as at the municipality level, we have this municipality master plan, who is very important, and political guidelines and strategies approved in city council. That can be municipality climate and energy plans. And at the tactical level, municipal planning at general level, down to zoning plans, building applications, and very important, public procurement. At the operational level, it's important with the practical work to fulfill municipal planning towards different actors. Very important with good examples project from a logistic perspective. And we will have a look at one of those. And this is acting guidelines at different administration levels in Norway. And the orange represent the state level, the blue the county level, and the green the municipality level. All three of them can influence on each other and should, but the color indicates where it has the most impact. So you can see that the Plan and Building Act with the Building Code have an impact on all three levels, but the Climate Change Act and the Pollution Control Act and National Transport Plan should have much more influence on county level and municipality level than it have today. And the green ones are at the municipality levels, but the public procurement are on all three levels and are very important to have that the municipalities can make a good work, I think. The status of legal and policy in Norway. The Norwegian Environment Agency points out that municipalities and businesses can work together in setting requirements to suppliers to obtain fossil-free or emission-free construction sites. It is nevertheless at the municipal level that the important provisions for the relevant construction projects are decided. And as I told you a little bit earlier, a review of the Planning and Building Act and the Building Code shows no specific requirements related to fossil-free or emission-free construction sites. At the right side, you can see the Norwegian planning hierarchy at the municipal level, and from the very top, you have this municipality master plan and zoning plans. And I think it's important to anchor the goals from emission-free construction sites and logistics as high up in the hierarchy as possible. Then it will be much easier to fulfill it down onto building application and building and the zoning plan. Zoning plans cannot demand higher ambitions than the minimum requirements given in the building code in Norway. And the building code is the TEC 17. And in a way it can. If the municipality or the state owns the ground, they can, but you cannot force a private developer who own their own site to do it. And in Trondheim, where I am from, 70% of the new projects is owned by private developer. So it's important that the legalization can also push the private developers. Many of them are interesting in new solutions, especially the big ones, but not everyone. And I think that is the same for procurements. But there are a lot of good examples. This is from Oslo, Norway. On the left side is the first fossil-free nursery school. And on the right side, the first emission-free construction site. So, and this is in Oslo. Oslo municipality is the front runner in Norway and has been using fossil-free, emission-free construction strategies to address challenges and needs of projects in order to achieve environmental goals and ambitions. Oslo Bygg, who is responsible for the municipal buildings, has been one of the front runners in developing and realizing emission-free construction through their procurement procedures. They are very good with the procurements. And I think Christopher Venas from Oslo Bygg will talk more about that later. So this is some of our main findings. We have a comparison between Norway, Sweden, and Belgium. And in Norway, we can see that there are many plans and strategies at the state level, but few absolute requirements. It's in the municipality level that Norway is leading. the way of giving good example for construction sites and other logistic activities. In Sweden, there are plenty of laws and regulations stipulate at the state level that affects how construction logistics are carried out at the local level. The problem has been that the municipalities have not used the opportunity to take the lead in the same way as in Norway. In Belgium, who have a different organization than the Nordic countries, and the rules are not enforced at the national level as the decision-making power cascades most often down onto the regional level. So they have a much bigger regional level in Belgium. The municipalities are responsible only for projects with a smaller impacts. If you look at the figure below, the color intensity shows the level of importance, where the darker shade of blue, the more important the level has in the decision-making process. And as we have talked about in Norway, very much happen at the municipality level. In Sweden, at they are on the top level, but and in Belgium at the regional level, the state level in Sweden. So this is yeah, there are some big differences here, but a lot of similarities too. And in the end, we have made these policy recommendations, measures that can strengthen the policy framework and improve the environmental performance of construction logistics at each of the 3 hierarchical levels. At state level, it's very important to focus on reducing emission by setting mandatory targets, recurring data gathering to follow up the targets, setting good examples for working towards reduce climate impact by utilizing construction logistics setups in state commissioned projects, support cost reduction through incentives and subsidies by provide and stimulate the required infrastructure. That could be electricity, hydrogen, transport machinery, waterways for new markets. At the regional level, it's important to increase awareness at the political level by to increase testing in pilot projects, follow up the mission updates based on knowledge gained, and clarifying and unifying the roles, mandates, and legalization of different municipal administrations. That could be building regulations, traffic management, and environmental concerns. And you have to set clear, objective-based incentives to allow for competitiveness across regions and states. And at local level, it's important to aim for high activity and high ambitions in the tendering, pursuit, and building process, and have focus on testing solutions and generate ambitions and contribute to research. And of course, have a very good projects that you can show that it is possible to do it. Thank you for listening to me, and please contact me if you want to discuss legal framework and policy making.
Thank you, Lars-Arne, for presenting. And we will soon now go back and I will share my screen here again. I would just like to mention meanwhile that if you have any questions to Lars-Arne, then you will be able now to put them here at Menti or directly into Zoom. And for you in the audience, as always, think about them and we will have time later. And I will ask you as well, Lars-Arne, if you can stay with us, but please mute and also make sure that you will be available later on so you can answer their questions. We will have that in the later part. But now it's time to move on to the next stage in the presentation. And we are now going to focusing on the construction logistic games, which will be presented by Monica Bilger from Chalmers. Monica, I hope that you're with us now and you're prepared. And
yeah, I hope you can hear me. Yes?
Yes.
Good.
And I will also give you the click so you can respond for this presentation.
Good. 2 things to carry. Okay. Hello, everyone. I need to do the first click. Yes. So I'm Monica Bilger. I'm a professor in architecture and visualization from Chalmers, and I should not move far from the cross. Sorry. When we started this, the civic project, I was also part of the civic project. We didn't really think about games. It was visualization, and I was thinking about that. And we had a meeting in Amsterdam, and during that meeting, and I saw this tactical, strategic, these levels. I saw the different players, and then after a while, I said, "Hey, everyone, we have a game here. Shouldn't we play that one?" And then we realized that okay, let's make a game. So then we started, and in the Mimic, it has actually been developed much further than by Carl Bergström, especially from who's not here today. So I will just start. Why serious games? Why could it be a good idea? I have been working with games in different projects, like 5 games, I think, sanitation planning and urban planning, and now then in construction logistics planning. It's this with engaged involvement. It's possibility with games can motivate learning, and you have a possibility to try different stakeholder roles. And it's very important also with this time to reflect together and having fun together. It's a very good way of actually reflecting and also create trust, which has been shown in research that is an important part of the game. So if I tell you that it's good with a game because it's fun, it's not just because you have a fun time, it's also it will give you a chance for another grounding in a project. You can understand different perspectives. So this is I think this is from the end of Civic in a way with the game we had at that time. We had a fun play here. Yes. And this, I have to take this half maths again because I love it. And it's also because it's so important. This is where we have had the core. We have been discussing this so much during the Mimic project. And I, of course, have been on this side, the workshop process and how to get in all these different tools. So the games that I will present one is up there on the scope, strategic level, the Mimic board game, and the other is here on the scenario level, the Mimic mega game. So, and the development of these games, here is an image where Carl Bergström is actually showing the development of the board game, which went through many different phases before the final one that's outside the door. And then we have the other game, which is the mega game, because we realized that the Mimic board game has a limitation. You need to play it on a site. You can not be so many people at the same time. You can have several games, but with one game you can only be 5 or 6, something like that. So therefore, Carl Bergström developed a mega game that we also have tested in different ways, where you can be many more in the game. There is no real limit, actually. You can develop it for many people. So the board game is about this. The goal is to finish the constructions in time, to avoid congestion and disturbances. You have a construction site, of course, and you have material that should be transported to the site. And you have also the other main contractors who also have material that should be transported. So we only have 2 rules. It's the city and the builders. They do have different things they can do, different actions. And the builder scores points for finished construction stages, and the city is evaluated on total disturbances. So there is a way to win, but it's different for the city and the builders. And learnings, we have 2 key insights from the testing of the game, has to do with that actually the specific game design patterns influence the game's purpose, and we had to change the game mechanics so many times. From the beginning, winning wasn't really so important, but we realized we had to have the motivation to make it realistic. We also had more stakeholder roles, but that became too complex and it took too long time to play, for example. So some things like that. Also, the timing is a real problem sometimes, that it takes time to learn to play a board game, and you don't have a workshop time for hours. You have to have it, keep it into some kind of time limit. And the other one is actually which really Carl pointed out as a very experienced game designer and game researcher, the difficulties with different player types, and especially then the very inexperienced that also could be too careful and have take very long time to learn the game. And then we have the too aggressive, usually more, doesn't have to be an inexperienced, could be experienced, it's a type for what everyone can be, or too invested, or so investors think it is really their own personality and has a problem with that they are playing. Not invested enough, I don't care, doesn't matter what I do, okay, you can understand. Non-compliant, not following rules, or even word boundary testers, just playing for testing how it works, really. All of these types, we are probably one of them ourselves in one way. We have to think about that because that's how people are. So we have to be able, so the most important is also that you have a game facilitator, you have someone who keep it together, who can help out, who can make the impact of the game better, and also keep the time and help out when it's needed. So we need what? You need one who actually knows the game well and knows the aim of the game. The Mimic Mega Game that we then developed to have something in another phase of the workshop process, and also it's more of a gamified workshop. Make this game. It's a role play. We have 6 player roles here. And the local authority, the developer, the citizen organizations, the logistics service provider, the main contractor, and craftsmen. So you recognize them. And in this, we want to have at least 2 players of each role. So that's at least 12. We have played it with fewer, so it's okay. But it's better if it's 2 of each role. You have a fictional construction project. We have realized that we should have it like a map or something, so it becomes more realistic for everyone. And the task for the whole group is to come up with a construction logistics setup suggestion after the role play is done and the mega game is over. You have role instructions for the perspective, the goals, the objectives, as well as a special ability. So for the craftsmen, for example, they can go on strike. Or the main contractors can say, we're not bidding. And then you actually will not manage, because here we actually should come up with a solution together. And then we have a setup of discussion. So you have a discussion within the group, the main contractors discuss and have an agenda and their strategy. And then the logistics solution provider, they are discussing their stuff and the developers their stuff. So and then you have mixed groups, and then you have other mixed groups, and then you have the whole group. So it's like a setup of different discussions where you try to reach a conclusion in the end. And you try to persuade each other between the groups and things like that. So it's lots of negotiation, and it's very important if you are working with these kind of mega games in a serious situation, that you actually have people who actually really know the kind of logistics, who are sub-game leaders of the small, if there are 2 different groups, mixed groups that will actually develop 2 different solutions, that they actually have very good knowledge about logistic solutions also. It helps. But this game is quite easy to learn. It was fast to start playing. So we could see that it worked both on Zoom and IRL. The worst thing on Zoom was actually for the game facilitator, who couldn't really see what the others were doing. And when we compare it to playing in real life, it also provides so much about the ground for cross discussions between the groups. You can actually shout onto the other side of the room to the other group. That's possible. And that also that actually, I mean, it's when you are in the real life, we had much more better possibilities of using pen and paper and things like that. It also makes it a little bit easier. So conclusions from this, that both the board games, they showed to be fun and create a base for discussions. They worked in a way. Lessons were learned on the difficulties when designing the board game for non-experienced players. The mega game works well, both online and IRL. However, IRL creates more interaction. And the next step will be to evaluate the workshop designs including tools, for example, the MAMCA tool, other optimization scenarios. That would be the funnest part for me to see how could you do that together with a mega game, or how can you use the construction logistics card separately for brainstorming or discussion or education. So there are so many things if you just see these as parts of a toolbox. That's what so that's for me. That was quick. Yeah. I was quick, wasn't I? Did I forget something?
No, thank you, Monica. And again, please, if it's possible to mute it.
Yeah.
And I can take the clicker as well. Thank you.
Yeah, I will do this.
Thank you for your presentation. And as always, I would like to remind you again, if you have any questions, please go into, I can see there are already some questions, probably this is from before. Go into Menti and put them there or through Zoom. And if you have them for Monica, keep them in mind, we will continue. But now it is time for our next presenter. And again, now we're gonna go online and we have our presenter there. So I will stop sharing my screen. And soon I will let you, Martin, sharing your camera and voice. Martin is Swedish from the Swedish Transport Administration, and he's going to talk about the need for data in construction logistics. So with that, I will stop sharing the screen. And Martin, I can see you now, and could you please talk so we see if we can hear you as well?
Yes, am I audible?
Yes, we can hear you very well, Martin. So please, I would ask you now to share your screen.
I will try to find the right button. Can you now see my screen?
Yes, I can see it. And please, I will look into if you can present it as well. Great.
Is it a good?
It's the right mode, Martin. So I will now hand it over to you.
Okay, thank you. And thank you for inviting me to this conference. I work in the Swedish Transport Administration in the maintenance department and initiated this project of keeping track of the flows through mainly through our contracts. And I will tell you about it very briefly. We call it in Swedish ELSA, Energiledningssystem för anläggningar, and it's a bit difficult to translate to English. You will see some various translations during this presentation. Energy management systems for plants or for construction infrastructure. And the aim is to keep track of our metabolism, our flows of energy and material, mainly through the contracts, the works contracts. And we are starting by following up the energy turnover and the climate impact gases and excavated masses, earth. And we also are aiming soon to start with environmental product declarations of the things we buy. What do we want to capture? We want digital messages to the TRV is a short for Transport Administration. To our system, ELSA is going to be an internal computer system within the Trafikverket. And we have, since last year, a digital channel of entry into this flow. And we want to use the delivery note in digital format by the Swedish building branch electronic business standard. And I will tell you a little more about that soon. First of all, we want to keep track of our climate impact in terms of fuel used by lorries and machinery by our contractors. Secondly, as I told you, the excavated masses, where are they taken from, how are they handled, where are they brought, how much are they, etc. Thirdly, the EPD of the goods that we buy. Probably we will start with things like concrete, asphalt, and the like. Asphalt and paving works. We are already working with that, but it's not yet part of this system. And we have been trying to save energy in this field for years. Electricity is written in green because we already know we have 12,000 measurement devices on our road and railway networks for electricity consumption. We know exactly how much each of them is consuming or what's connected to it. And in most cases, we know exactly what is connected, but some of them on the railway side are there have very many things connected, so we are not quite sure of everything. We also have a periodic system of about 100 elements. Many of them are interesting for us. For example, heavy metals. We have mercury in some of our lamps. We have cadmium and other interesting elements in our electric devices of different kinds, and it would be good to keep track of where they are and what they are doing. And these elements may also be joined together to form chemical compounds. And many of these chemical compounds are found on various lists of dangerous substances and substances to be phased out, etc. And we also want to keep track of them. But this is still for the future. We are not there yet. We have not started to work with this really yet. Not in the ELSA context. I have seen this as a 3-stage rocket, this project. First stage is to know what data can we collect and what do we want to collect. When we do pilot trials, we find out how we can require monitoring by our contractors, and this should be entered into our contracts. And when they start to work, we will collect data. And it is really only then that we have a solid basis for requiring savings of, for example, climate emissions. Now we are doing this already, but it's a little blindfolded. And sometimes we have to go back or change our requirements as it is today. To share digital data, there are 4 major requirements we have identified. One is it should be digital. Secondly, it should be standardized. Thirdly, the requirements should be so specific that you can give them to a computer programmer and he knows what to do on a very detailed level, that is. Fourthly, we have 100,000 companies within the sector in Sweden, and many of them are one-man companies. They all need to be able to join, so it should be easy to join. Perhaps you have seen a building site. Often we have loads and loads of paper, and in environmental follow-up, we have loads of Excel tables and so on, and one is not like the other. We don't want that. We want to have standards. Now we have a development where companies and authorities they are opening their own portals and saying, come and report in our portal, or come and order in our portal. And one portal cannot talk to another one. And this is not what we want. We want them all to be able to talk to each other, not through portals, but the system should be able to talk to each other directly, not analogically or manually. And if you look at the chain of supply, we have clients or authorities, and we have contractors and subcontractors in several levels, and they have computer system support. If they start to require things in different ways, by different systems, by different standards, and this will multiply, you see that very rapidly it will not be possible to handle this. This is not a sustainable way of working. And we need it to be simple for everybody. We have discovered this standard for what we are looking for. My computer architect was looking 5 years ago. We need this information. What system is there to help the contractor? We found one system. It happens to be placed in Sweden. And so far, we have not seen any alternative to this system. It is a standard. It is an association, non-profit association of 120 companies and organizations. In total, the number of members is thousands, if you include the organizations. And we are a member since 4 years. And we believe that this is the way that we have to go forward, using a standard. A contractor and a subcontractor will have a delivery note, digital delivery note with commercial data, and we increase it by environmental data going into the transport administration. And sometimes, for example, we will be making analysis of, for example, climate emissions using this data. And sometimes we have our own contracts with a deposit site, for example. So we will also have the commercial data by the same, all this information goes by the one and same digital delivery note. This is the great advantage. When we go digital, we have less lag. Instead of having a report per project and maybe year per how much climate emissions they have done, we will have one per vehicle and day. We have much more time to solve the real problems instead of copying documents by hand and so on. And we will, one experience is that the number of errors in what is reported is reduced drastically when you go digital. And we will also have a better foresight, early indications of possible deviations in the projects. The Gripen emissions, how is the project constructed? We have this internal to develop the system for the transport administration, and we discovered this standard, and we want to have pilot projects, trials, and we will do this since last year. We have an innovation project to try this with a number of companies, and they are in this project developing their computer support systems. And we will develop our procurement requirements so that we can have a rollout in Sweden on this basis. And we have also discovered that there is an EU project federated for goods transport digitizations. And we have already been accepted halfway through the EU project. We have been accepted as a member with a living lab, 22nd of this project. I will see how much time have I left. A few minutes. I feel like I'm in a hurry. Our innovation project at present, since last year, we are working with these 3 companies. 2 of them are contractors, one for maintenance and one is mainly for investments. And the third one is a computer company, Cubicom. And we are doing this reporting of fuel consumption and excavated masses. For excavated masses, it is working since March. And there is also a short film about that. Unfortunately, it's still only in Swedish. And we have started slightly to look at the EPD also. When it comes to fuel, we have asked the biggest organization to introduce some new codes, because we want to know not only how much fuel is consumed, but also how do you know that? Maybe you're just counting standard consumption by some not measured, once measured, and you apply it to all, or per hour or per work done of some quantity, or maybe you combine per kilometer with full load or no load, for example. Maybe you have a journal of how much you are filling your diesel, you are filling your lorry. And maybe you are reading the computer, or you are having this, you're getting this figure as you're the owner of the vehicle, you get them from the factory, the producer of the vehicle, or by other means. And we also want to know how often do you read this measurements. And if one lorry is going for 3 different clients, 3 different projects in one day, how do you distribute this consumption between these 3? By which method? We want to have all this also reported to us? How do they know how much they have consumed? Now, this is what we have agreed with our project partners last fall. It's in Swedish, but it's on the BEAST order or delivery note standard. The head and each line, the 1 to 7 is the head, the note number, date, version number, and supplier, and so on. And in the line, you can see what start and end time of which registration number of the vehicle, how much, what kind of fuel, how much fuel, and how far did you go, and how long time did you go, and how did you measure, etc. And how much renewable fuel. The black lines go unchanged from the subcontractor to the contractor to us. The red lines stay between two partners because it does not concern the third one. And the green figures at numbers 20, 21, 22, they are the new codes which were introduced in February this year because we asked for them. So we find that BEAST is a very handy organization to work with. And this is the same for excavation masses. Some words are in English, but it's about loading site and delivery site of excavated masses. And this is for the environmental product declaration. So far, the EPD is concerned only with climate emissions. Of course, this is only a first step because an EPD can take account of much more than climate. But it's a handy end to start in because everybody's asking for it. So that's where we will start. And oh, I'm ahead of time. That's very good. I was in a meeting with a BEAST construction committee 3 years ago. We were around 20 people around the table. And from contractors, from subcontractors, from companies delivering various building materials, from computer support companies, maybe from a municipality, but I was the only one from the government, from the national government for the transport administration. And then somebody asks, we have been doing these practical projects using the BEAST standard now for 6 years, or was it 7 years? And we have done more than 500 projects and everybody is very happy and nobody wants to go back to the old system. Everybody wants to go on with this. And still, it is not spreading. Why is it not happening? And somebody else says, well, the companies don't invest in it until they know that this is what will be. But how do they know that? And then somebody says, large clients must take the lead. And then everybody looks at me. Thank you.
Thank you. And just if you give me a minute, I will stop sharing your screen and we will again start sharing our screen here. And it is now time, we're still keeping very well on the schedule. It is now time for the poll question number 2 and a break. So please, if you have questions, again, save them for later, think about them, and we'll have time at the end. But first, I would like to introduce you to the next poll question. And it's like this, I can see that there's one answer already. It would be, what's the most important thing to improve construction logistics? And we have 5 alternatives. Unfortunately, you only have one here to choose from. If you have others, maybe we can have it in the chat or here, so we can comment when we get back. What we'll do again is the same code, and you will have time during the break to answer and think about it. Until then, we will have here a small break, and we will be back in about 15 minutes, so 14:05, and I can show it here again, and then we will have Christopher from Oslo Bygg that will present. So 14:05, we will go back. Until then, please answer the question and have some break. Welcome back. I hope you had a good break, and we are now gonna go into our final session. Please, for you who have presented before, if you still have your camera on Zoom, then I would ask you to take it away. And now we were just focusing a little bit, some of you have answered about the question that you see in front of you. What's the most important thing to improve construction logistics? And as you can see, most of the answers are towards early planning. But we've seen some of them also with well-defined procurement criteria, stricter regulations, and consensus on the problems between different actors. And of course, we probably need them, all of this happening at the same time. But it's good to know maybe where you think the most emphasis should be here. And maybe what we presented today from the MIMIC results has influenced this result as well. If you have more time, you could continue, of course, and vote, but I will also here leave you to the next one. In case you need to have more questions for you online, you can go into Menti as well for you in the audience as well here. But with that being said, now we're going to move on, and I will then now present Christopher Venus from Oslo Bygg, which will present learnings from MIMIC and challenges ahead for your organizations. So with that being said, welcome, Christopher. Here's the clicker and the floor is yours.
Thank you so much. I hear that I'm on, and I'll start. My name is Christopher. I come from Oslo Bygg, and I work as an advisor in the department called Sustainability and Innovation. Firstly, I'll talk a bit about Oslo Bygg, since we're quite new municipal organization. Then I'll talk a bit about our way into MIMIC. I'll say something about what we learned through being a part of this project as a partner. And I'll finish up with speaking a bit about our perspectives on zero-emission construction and showing a bit what we are doing and what we want to do in the future. Yeah. So we're quite new. We started operating on the 1st of September. Before, we were 4 minor municipal building owners, including Omsorgsbygg, which was a part of the project from before, and I represented before. So we're public, and we do public procurement of buildings. I'm going to show you a bit of our portfolio, so you just understand what we do. No offices, not that many houses. We do nursing homes, schools. This is the new main library. And we have sport facilities, the Nordic ski arena, and we have the newly opened Monk Museum, many kindergartens, a lot of fire stations as well. So that is a bit about us. I'm not going to say anything about the climate strategy, but we do have high ambitions in Oslo. And this is something that has been decided from the politician side. So it kind of affects our approach to this concerning logistics from our side, I must say. And I'll talk a bit more about the specifics when it comes to construction logistics. So our starting point was basically the fossil-free construction sites. We had some dialogue with the market in 2016, and we implemented this as a minimum requirement on our construction sites in 2017. Then we had this pre-project together with Sintef on zero-emission construction sites or emission-free construction sites. And that was basically how we ended up in this project. And that's kind of our background. Maybe some of you at home are wondering, what is this fossil-free thing? So these are the fossil-free energy carriers as we define them in Oslo. So you could switch diesel with biodiesel and still fulfill our criteria. But we want to move to zero-emission, meaning that we only accept electricity, hydrogen, and district heating for machinery and transport of first bulk excavated masses and energy and heating on the construction site. And then in 2025, we'll move on to having zero-emission construction for all our construction sites that are on municipal contracts. For now, since 2020, we have had the award criteria to promote the zero-emission machinery. And I'm going to speak a bit more in details about that because that's kind of important to understand our strategy when it comes to the building sites and the transports to it. But first, I wanted to say something about what we've done in Mimic. We started out with Tåsnhjemmet, a nursing home, which was under planning with several good qualities, quite close to the city center, plus house. We have a lot of wooden materials, so it's pretty low carbon print on the material usage. It was supposed to be BREEAM Node Excellent and also fossil free, the construction site. We started off with some interviews with some key actors on the site in the planning. And they actually told us that the traditional turnkey contract could serve as a kind of barrier to the early collaboration as has been promoted in Mimic. So like our traditional way of performing the project, it kind of hindered us to involve the constructors and the people that had the knew the most about the site itself in the early phase. And also we found that if you do innovation, it's not a barrier to achieve good construction logistic. And several interviews had experiences with cross-laminated timber structure, which is prefabricated, brought to site, brings in different logistics, and that might actually be good because you need to plan better and don't do the same as you did in the last project. BREEAM is also another good driver for good logistics. However, a lot of reasons. Things stopped at Tåsnhjemmet. There were problems with the regulation, so the zoning process, I mean. So we needed to stop the project. So we had another case into Mimic that Selamawit has told you about before. I'm not going to say a lot about it. It's a big emergency ward, our biggest project, a lot of excavated masses. So we investigated the importance of that. And it gave us some good learnings, both on like the construction logistic activities and the importance of them, but also something on like what we have to do on the data collection side to, I don't know, get better analysis. So back to Tåsnhjemmet, it wasn't that big part of Mimic as we wanted, but soon it's now actually in the detailed planning, where it's still a plus house, it still has very good qualities, and we actually did manage to get some logistic elements into the project, and actually through using our award criteria. So that was what I want to talk about next. We do have mostly electric machinery planned on site. The details are still going to be planned. The start is not until next year. But I wanted to tell you about how we achieved at least some good logistic solutions on this site. And I'm going to do that as a part of the last part of my presentation on towards the emission-free construction logistics. So this is basically what we've done since 2020 in all our construction projects. We have to evaluate environmental as a part of the criteria when we procure, and we have to have it at about 20 or 30%. Construction machinery is always a part of it. It's larger than it says in this figure. And the same goes for the transport of bulk materials. And we also have quite an open criteria on other transports, meaning that in all our offers, we get something on the logistics, even though it's mostly related to the technology. Something is also about the more effectiveness of the logistics setup. I'll just show you a bit how we actually do it. This is for the machinery only, not for the transport, so only on the site. But basically, the contractor has to tell us what kind of machinery he wants to bring into the site and what kind of technology it is. And then we evaluate the machinery setup, you could say. So the ones who have most zero emission solutions, they get the most points. And in the same way as if they offer a lower price, they will get more points. So that's the way we're doing it. I want to show a bit of the results. This is only from 5 of our construction sites with the criteria. You see that the green one with the electric machines, this is only machinery. For the small ones, there is already a lot of electric equipment on the conventional sites, but at least now we get mostly electrical and promote the use of them. And the large ones, they were not normally electric before, apart from the cranes. But now we, in most of our offers, at least the bigger ones, we get electric diggers in the large or medium category. So we see that it is working, and there are more heavier electric machinery on our sites now than it was 1 year ago and 2 years ago. I'll underline that with the lorries. We are asking for excavated mass transport by electric lorries, and we see that from 2020, if you see the bottom here, it was 1% in Oslo that was newly registered vehicles that was zero emission or electric, and so far this year the percentage is 6%, so it's increasing together with also the vans, which the municipality is also asking for in other contracts than the construction contracts. Yeah, I want to go back there. Oh, I was so quick. Oh, nice. I'll talk a bit because I wanted to show you this before I go to the last slide, because we do have quite high ambitions on the climate side, and that kind of affects our thinking. And we're not only going to reach in 2025 zero emission on our own contracts, but it's going to be also for the other builders in the town, not only the municipal builders. So all construction should be zero emission in 2030. And the zero emission heavy transport is also like a big project, which I'm not that heavily involved in, but it also includes the zero emission zones inside Oslo, starting with the pilot zone of the city center in 2023, hopefully, if the government allows it. And that would also affect our construction sites. So that's what I'm trying to say on this last slide. I threw in the smart governance concept here. It was more for a way, I find it very nice to kind of handles to kind of a way of thinking about the construction logistics. So I feel like on the strategic level, we have like a policy framework which is quite clear. It supports sustainable construction logistics, and we do like have a clear way of how we should think about these issues, even though it's not like really clear on efficiency. Bringing in electric machinery, it kind of affects, you don't want to waste the energy you have on the battery. So it will kind of, in the same way as we said before with the innovation, this might help the constructor to think about the machinery earlier, and it even helps us thinking about the logistics from an earlier stage. So at least it helps us a bit. I also wanted to mention that now we're Oslo Big, we have a bigger portfolio and want to see more of our projects together. That means that the connection between the project might like strengthen us, and these kind of consolidation centers and these thoughts might be more relevant for us when we get these bigger projects, several closer to each other, that are run by us. We also see this with the increased data collection. I really like the last presentation. We need more of it to enhance the analytics on the tactical kind of level. I think that's where we have most to go on, because that's what's going to help us to develop more advanced criteria, also taking in efficiency in a larger degree. Because in the end, on the operational kind of level, we do have the procurement criteria today, which could be further developed. We will most likely have some pilot projects in the zero emission zones that would be very interesting to testing more of the mimic concepts. But in the end, we kind of need to put the constructor, we need to play the constructor and the people that are delivering to the constructor in a better position than we've done so far. And I think that's like kind of where we want to end up. through developing our both requirements and criteria, and it will still, I think, be up to them to kind of solve this solution for us with their competence. Yeah, that was basically what I had. So questions afterwards, and then Rodrigo, it's up to you.
Thank you, Christopher. Thank you. Yes, as Christopher said, we will very soon have time for your questions, and so please put them in at Menti or prepare them in your head. But now we have one final presentation before we go into these questions and discussions, and that will be from Anna Fredriksson again from Linköping University, and Anna will now talk about the challenges ahead, which is always a hot topic. So please, Anna, here you go.
Thank you very much. Nice to be back. I hope you enjoyed the day as much as I have. I always think when you come to these final presentations that, wow, what a lot of things we have done in this project. And how are we going to take it forward? That's also a question. So it's just not stay in one project. However, I want to summarize a little bit of what we are thinking of what do we need to do. And I think one of the issues, I see I've forgotten to animate two things, but earth and rock masses. And several of you have lifted this issue with the earth and rock masses because the major part of the heavy transports are related to earth and rock masses. And the question very much is, how do we balance it? How do we accomplish circularity, and how do we decrease the transport impact of these earth and rock masses? And this is the picture in the background is a figure from Ostlänken, a project in that's going to be built by the Swedish Transport Administration in the eastern part of Sweden, a railway project. And there you can see we're going to have a lot of earth and rock masses. We're going to produce more earth and rock masses than we're going to need. So we're going to have a balancing problem. And then the question is, how do we balance this? And in order to balance it, we need to think of where to balance it, between what? Should we balance it on a local level? Should we balance it on a regional level? Or should we balance on a national level or even an international level? So, and depending on how you decide to balance earth and rock masses, it's also going to impact on the transports. So it's going to impact on the transport costs and the costs. And the balancing is very much about space. In order to balance, have you thought about it? Once you're going to balance, what does it mean? From a planning perspective, it means that we've got something available when we talk about earth and rock masses. We've got something available ahead of when we need it. So we need to store it in between. And that storage can be for just a few weeks, or it can be for several years. And then we need space. And this space needs to be located somewhere. And where we locate this space is very much going to impact what kind of transport mode we can use. So can we use water? Then we need to be close to the water. Should we think of, we talked a lot about OCT transport earlier, but then we need access to these roads that can carry the HCT transport. Sorry, I thought I was just breathing so much into the microphone. So the location becomes extremely important. And what type of services should we offer at the location? How do we handle the materials? Should we upgrade it? Should we crush it? Should we just store it? Should we move it around? Should we mix it? And how should we, a lot of what Martin from the Swedish Traffic Administration talked about, how can we keep traceability? How can we know the impact of these materials? Because if we want to reuse them, the problem with all circularity, I don't know if you have thought about it, it doesn't matter if we talk electricity products, if we talk plastic, if we talk earth and rock masses, is the traceability. Because what you can do with new products, with virgin materials, is that you have the traceability. You know where you collected them. And in order to increase circularity, we need to keep track of traceability. And then we need also to see what type of services can we offer that improve traceability, but also decrease the need of space and increase the inventory turnover rate, because inventory turnover rate is a very logistics specific concept, but it's very much about how quickly can we get it moving. And the more quick we get it moving, the more money we make out of it. And as looking at Ole, because money is very important. It's important because we are in, there are companies, and companies have to make, they have to make money. Otherwise, they will not stay in business. And if they don't stay in business, it doesn't matter how good you are at environmental issues if you're not longer in the business. And also again, coming back to what Christopher said and also what Martin said, that it's the large developers that have to take the leads, because, and especially the public developers, because they are not that dependent on the final line as the private ones. And then, of course, these are going to affect what transport impact we have and what costs we have. So I think what we have seen in the MIMIC project and the Civic project and a lot of other projects which we're involved in is that we have focused a lot on house building and the house building material flows. But as Selamavit presented earlier, the impact, the large impact from an environmental point of view, it's actually the earth and rock masses. So I think there will be a lot of focus in the future on the challenges with earth and rock masses and its storage and transport impact. And then we have electrification. So we need to electrify, as Christopher went into. We're going to electrify the sites. There are already today rather good alternatives for machinery. And as some of you in the audience know, there is a lot of research and thoughts going on, and also there are coming the first vehicles for the deliveries. However, with the electrification comes two questions. And this is a friend of mine and a colleague in Linköping, Per Lindahl, who's talking a lot about it, because it takes about 10 minutes to refuel a heavy truck with diesel. But it takes still a lot more time to recharge a heavy machinery or a heavy truck. And that time, once again, it's money. It's lost money. And then at the same time, these electrical vehicles, they're more expensive. And they take a lower load, meaning that you have to have more of them in order to transport and move the same amount of materials. So there is a problem related to this that we have to solve. And it's also the question of how we have developed our systems. So this is a picture I borrowed from Ecoloop, who's also working a lot with earth and rock masses. And the problem is that if we want to move into electrical vehicles, we need to think on how we route our transports so we can accomplish the recharging when there is a time for a break, so we get a good resource utilization of both the vehicle and the drivers. And we also need to think of how we accomplish that in combination with the circularity of the earth and rock masses. So how can we move the things as few times as possible with electrical vehicles without the electrical vehicles increasing the amount of vehicles in the urban areas, without taking longer time for construction sites, and also that we also can handle the limitations of available electricity or power in the system. So we need, in order to success, we need new ways of organizing the transports in construction projects. We can't anymore let it up to be for the drivers, because that's one of the most frustrating things I get, like when you come out and someone says the best transport planner is the driver. No, the best driver is the driver, but the planner is someone who has the overview, who can look at several transports at the same time, who know what nodes you're going to drive between and so on. So we need new ways of organizing the transports in construction project, and we also need better coordination between the site and the transports to and from, because we're going to share the recharging stations. So how do we make sure that the recharging at the site is available for the lorry arriving, and that's going to be a move away. So we need to coordinate between the machinery and the lorries. And since these electrical vehicles, machinery or lorries, it doesn't matter, they are more expensive. So if something is more expensive, we have to utilize it more in order to not be more costly to use them. So we need to think of how can we then utilize the machinery more hours at the same time. And then, how to balance investments in loading equipments and vehicles. So we need to start thinking of, instead of having these like very complex movements between construction sites, we need to have this very neat and easy way of moving between them. Because we can't have this Tesla. Have you all seen that when you want to recharge during winter season, and everyone in Norway, this is from Norway, where they are way ahead in electrical vehicles, but we can't have these recharging queues in construction, because then it's going to be so extremely expensive to build. So then zero emission zones, I'm sorry, they're not going to be reality in that case. And we also need to think on then, as I said, how can we utilize the hours better? Because these things are more expensive, we need to utilize the hours much more better, and we need to start thinking outside 7 to 4. So how can we do more during nighttime and so on? And also when the electricity is cheaper. Once again, 50% of the construction trucks arrive between 7 and 9 in the morning. That's when everyone else wants to drive. If we want to recharge our electrical lorries and machinery, maybe it should not be during daytime when all the industries also utilize a lot of electricity. Can we think of other ways of utilizing it? Or with sun charging or whatever. But we need to think about this. So this is going to be challenges ahead as I see it. And as a lot of us have been into data. We need data. Because with data we can start doing simulations. Me and a colleague, Ahmet, we have collected data from 40 construction projects now. However, this data is of such low quality, so it's almost impossible to make a statistical viable simulation. And I know Selamavit and you and Nicola, you have collected data. Nicola, you have also had a lot of problem with the data quality. And Selamavit, you have collected data from one project. But in order for us to do simulations, we need data from a lot of data, as Peter talked about. We need data from several thousands of projects, preferably. So how do we get hold of that? And we need to then think of new ways of collecting data. So in another project, I got very upset because they couldn't tell me how many trucks were passing the gate. So I have another colleague called Rasmus, and he and I found out that we could, of course, use these slangar, I can't remember the English word now, but these on the ground to measure the passings by the gate. However, that was extremely expensive to buy one of these standard solutions. Why, I can't know, because these what's the slang in English? Hose, thank you. These hoses, they are rather cheap actually. So we developed our own system and put it up at a construction site in Linköping. And with this system, we can actually capture the number of transports moving in and out of the site. We can see when during the day they arrive. We can actually see what type of vehicle it is. If it's a long vehicle, if it's a short vehicle, because you can see from the data pattern of when difference between wheels and when they pass the hoses and so on. So, and this system, it costs maybe 5,000 Swedish kronas. So saying that it's a cost issue of collecting data, I don't think. I think it's just a business or an industry that's not used of thinking of collecting data. But we also need that data to be combined with several other data in order to make these type of simulations that Peter presented. This is another simulation also made in Matsim, which we have done in Norrköping. So we have a similar Matsim model that Peter has over Vienna, we have over Norrköping. And with this one, we can actually see the impact of a number of heavy goods vehicles, and how if we have 6 sites here in the center of Norrköping, and we know the transport pattern of those sites, how much transport they're going to generate, when over the day, when during the project time, we can actually see the impact on the urban infrastructure in advance, so we can simulate this. And with the help of this, we can also develop different arrival rates, thinking of the electricity, for example. So we have here developed different arrival rates, and based on this, we can actually identify then which type of arrival pattern will generate least congestion in the city. So with the data, we can start doing these kind of simulation and these kind of developments that's gonna help us improving the industry in the future. So, and also, as Martin were into, can we, maybe I'm a bit a cynic, but can we use the environmental legislation as a demand to collect data? We can use that data for much more than environmental impact. We can also use it for productivity, for efficiency, but also on how we can decrease the disturbances of construction projects on the urban area in general. So yeah, this is where I see we're going to continue. And in order to implement it, of course, we need to start working on planning and decision processes as well. Thank you.
Thank you, Anna. Great. And if that didn't spark questions and discussions, then I don't know. So thank you, Anna, for that. And we will now move on to our next last part. We will have just a brief summary by Kajsa before that, but now we have time for your questions. And I will let all the presenters to sit down again, because it might take a little longer. So please, if you have on the chat, if there are questions, then we will take them, and now you will have the time to put them. If there are here in the audience as well questions, just raise your hand and we'll come up with a mic. And if you can target this, then please do so. Then I will let the person that can answer to come over here and then to answer it. By that, I will also share my screen here. I think, Lina, this was the one that was answered before. Let us start now first online, and then I will take one from the audience, if that's okay. So could you please go to, so we can hear him? Okay. Yes, could you please send it to, is it on?
It was two from Fredrik, two Christopher questions. I actually got some of the answers in your presentation, but I wonder when you actually what I was expecting some kind of award. I mean, if you have several different suppliers, and what I hear is usually the price is the winner. I mean, how do you emphasize the environment issues, or give some kind of award for that? So if price is much lower, how do you value the environmental zero emission solution?
Thank you. We will just give you the microphone, Christopher, if you please can stand here, and you will have the chance to answer.
Yeah, if I had time, I could have given a better definition of award criteria, but as you understand, price could be one award criteria. So in our case, we give 10 points to the one who has the lowest price, and we weight that by, let's say, 40%, then the lowest price get 4 points. And then we award, let's say, environmental criteria by 30%, and the winner of that criteria will get 3 points. So you say, so it's just like a mathematical way of trying to evaluate. So necessarily the lowest offer doesn't win. It does, like in many cases in our procurement, the lowest offer does not win. And yeah, how can I say, to evaluate price, that's like several theses only on like how you do that. And there's several models. We use like a linear model. And for environmental, it started getting complicated. And yeah, I could have used a lot of time explaining that. But for the machinery list that I showed you, if that counts, let's say 50% of the environmental criteria, that's 15% of the total. So basically the winner will get 10 points of that. So it will get 5 points, or now I was starting messing here, but yeah. And we do it by, we have like, it's a formula, it's available online, Oslo Kommune, and just search for, maybe I can share the link, but it's, I don't remember, but it's like, we call it in Norwegian tildelingskriterier, so it's available online. And there you can see how we calculate it, but we give points, basically. So larger, heavier vehicles get double points of smaller vehicles.
Thank you, Christopher. Do you have any comments on that, Fredrik, before we move on? Yes, we have one question from the audience here as well, if you want to.
Thank you. Björn Söderdahl again. I'm working mostly with waterborne transport solutions. But I also think when we talk about transport systems here and the different ways that we can reach fossil and emission-free operations, and this is probably to Christopher, then when you are trying to evaluate different solutions. In my world, this will have to be a mix of different solutions over time, where electrification is one, electrification described as batteries is one of several solutions. We have fuel cells coming on. We have let's say a temporary solutions which could be fossil-free electrofuels, for instance, and also some biofuels. How do you see this being used to pull in a more sustainable direction and in a balanced way? Thank you.
Thank you for your question. Christopher, do you think you can answer it? And maybe if there's others who would like to answer, then please just raise your hand and we'll let you do it. So please again.
Yeah. So right now we are favoring electrical solutions and hydrogen solutions. End of story. That's the way it is right now. If you were to offer another zero emission solution that like, it's just like how you by law define it. So it's pretty, let's say, complex. But if you can offer the same sort of zero emission solution, that means no direct emissions, then it would be counted in the same way as hydrogen and electrification. And this is a political decision. So they decided to be the front runner and to kind of support the development of electric lorries, let's say. And we need to kind of improve our procurement criteria so that we can evaluate, let's say, better, because, for example, for bulk transports is excavated masses, we are only considering the last mile, which is a weakness. And that's the way it is right now. And then we'll improve. And I think the most important thing for the ones who implemented these criteria was to support the development of electrical or zero emission solutions on these transports, and not that not that it was the best in every project, but like overall we see a development with more electric machinery, more electric lorries. And even though sometimes it costs a lot, sometimes it doesn't cost much at all, but it's just somehow someone has to try to do it, and they've decided to do it. I don't know. That was an answer.
Thank you, Christopher. I will see if there was anyone else here who would like to answer the question. Otherwise, I hope that you were happy with the answer, and we have a few other questions here. And maybe that was, you're popular here, Christopher. So I will read it, and if it's from someone here, you can also state it directly. Otherwise, I will read it. Did you evaluate the impact of electric construction machinery on the air quality in the city of Oslo? What is the air quality improvement potential of this type of machinery?
Short answer first. No, we haven't. We have not evaluated the impact on air quality. What I've heard is that the air quality in Oslo is okay-ish. It's not too bad. Yeah, it helps on air quality. Also, the guys running the machinery, they're also happy with less sound. Feels like better for them. That's what we heard. So I can't say too much about the air quality improvement potential, unfortunately. But what I can say is what I forgot earlier here, is that we also have an open criteria where we don't evaluate quantitatively, which we do on the machinery and excavated mass, but we have an open criteria for other transports, and that's evaluated qualitatively. So we do kind of support new solutions in that way. All right. Thanks.
Maybe you should stay, Christopher, this time to see if the next one is yours or not. I will just take, see what else here, but then I will take one from the audience. I will just mark the next one so you will have more time to prepare. But then we have one more. Okay, if it's a comment, then please, if you would like to hand it over, just state your name, please, as well.
Cecilia Flynn from Sintef. I've been working in Mimic as well. And we did actually ask we had some qualitative questions to the workers who were driving the vehicles on the 2 different construction sites in Oslo. And they said that they were, due to noise, less stressed and not that tired after working every day. But also they could feel that the air was much better on the construction site. So at least we see that it has an effect for those who work on the construction site.
Thank you, Cecilia. I would just also like to notify that we will share the websites we have and what else would be fruitful with you, either now directly on the chat or later on. So in case we've referred to something, we will share it later. Anna, I see we have a question for you here. I guess that's when you say Anna, it's towards Anna. Is that the case, Frederick? Would you like me to read it? Could you please take it via the microphone by Frederick and.
Sorry, I have to defend my old employer, but I think quite few. I could be wrong, but quite few of the haulier have this problem with weight limitation. Could be maybe more in mass transportation, but you know, you lose the whole engine. You take off the engine and you add batteries, so maybe it's not that big challenge.
Yes, Hannah, can you just please wait for the microphone, sir?
Yeah, maybe I was a bit sloppy, but the weight or the load that can be carried is mainly for the electric machinery is less. They have less ability to lift heavy thing, at least. Yeah, yeah, and the electric trucks. I would say with masses, it of course depends on what type of masses, but masses, the more you go into the stone area, the more it's limited on weight. So that's really heavy. So it depends on what type of masses. But then the main loss, I would say, is it's related to the time. utilization time because you need time for charging and so on. But of course, these are not unsolvable problems, but it's going to affect how you design the logistic systems, and we need to consider it. So I think what annoys me with all these discussions is that it's often so taken for granted. Yeah, we just take an electric vehicle machine and just put it in the existing system. No, it will not work. So yeah, it was a bit sloppy for me, but I'm not against electrical vehicles. I'm very pro them, but I just think we need to think of how can we utilize them in a good way.
Thank you, Anna. We have a few more questions, so I will continue on. And if it's someone in this room, then yeah, maybe you can ask it directly. Christopher, again, can you give some specific examples of requirements employed to secure emission reduction in the procurement process? If you feel that you repeated it, maybe you could just add something more if you have it. Oh, sorry, could you?
It depends a bit. Yeah, I have a lot of examples. But if you mean minimum requirements, because we do have the procurement, the award criteria, which we've gone into length on, and there we do get several electric machinery. But we've also had some projects, or let's say competitions, where we ask them to deliver the best EPDs in some specific materials. That's, yeah, we've done that as well. And we do have a lot of requirements related to emission reduction. So yeah, just send me an email, maybe I'll answer with more examples.
Thank you, Christopher. We will continue. We have just few more questions, so we will take them very briefly, and then I will let Kaisa come in and summarize as well. So this is a question, it's not targeted to anyone specifically, what I can see, but please feel free to answer. Was the effect of reducing truck traffic on car traffic considered in Mimic? Less trucks, less congestions, car driving becomes more attractive, more impact. If not, what is your opinion on that? So reflect a little, and if you would like to answer them, please come on up here. And okay, I see that Peter is getting up, so please, Peter, if you can stand here and answer it.
Okay, I will try to answer it. I'm actually not an expert on this type of questions, but it was in my presentation. Of course, these types of rebound effects always occur. When you turn on one screw and you have effects that you didn't think of, and you could actually make car traffic more attractive when there are less congestions. I think this is true. We can incorporate these effects, of course, in our simulations. So we would hope that the simulation models would also be able to predict these effects, so that you would move more cars to the streets when there are less lorries on the streets.
Thank you, Peter. And we'll take the last question as well before we move on, and that was to Anna. Did the contractor understand the user value of tracking the number of vehicles arriving at the construction site?
It's a good question. Not to start with, but after a while. We had another project where we put a smart delivery container at site, and where you could then come. I don't know if you have heard about these delivery containers, but where they have like lockers that is opened by Bluetooth, and then you can come and deliver things whenever suitable, and the guys at the site pick it up whenever suitable, and that removed a lot of small transports. Now we're moving from heavy vehicle to more vans. And in this case, we could see that the guy who was responsible for the internal logistics at that site, he decreased his walking distance with about, I think it was about 5,000 steps a day. So if you put it down to that kind of level, then yes, the constructors understand the relationship between a delivery, which Ole talked a lot about, a delivery which for the city is a transport, but for the construction site is a stop in the working. So a delivery means loss of productivity because you have to stop your work and go and collect the things. So once you translate the number of deliveries into lost working hours, the contractors become very interested in knowing the number of vehicles.
Great, thank you, Anna. And thank you all for your questions. And with that, we only have a few minutes left, so I will go back to the last slide on our agenda. And Kaisa has been analyzing a lot during this day, so you will have a few minutes to summarize your thoughts about it. So please, Kaisa, take it over.
Thank you. I actually volunteered to do this where we had the planning seminar. And I don't know if I regret that now, because we have a 3-year project behind us. So, I mean, it's not just to summarize, but I just want to give some personal reflections concerning this project and what we have been dealing with. So, I mean, this has actually dealt with construction logistics, and you might ask, I mean, this is not something new. The first buildings were made I just Googled it actually, 10,000 years ago. So, I mean, we have had some time to learn how to do this. So you might ask, I mean, how hard can it actually be? But, I mean, we have these dense urban cities that we need to deal with, and beyond that, we have requirements and demands for being both sustainable, efficient, and effective, and we shouldn't have any disturbances, as we could hear today. Also, so what at first glance seems like a rather simple task actually ends up being a very intrinsic and complex challenge, and that is what we have been dealing with here. And then what I think has been is so cool with the MIMIC project is that we have tackled this from so many, I'm sorry, I cannot stand still. So we have been tackling this from so many various perspectives. So I want to bring up some of these different perspectives that we have also, because it also became very evident today when listening. So we have had all these different various of levels of the system focused on. We have had the strategic, tactical, operation levels. Carolyn is now laughing. Am I still going outside? Okay, and we have had the state, regional, and local perspectives. We have had the on-site, off-site, and the city level analysis. We have had different methods. We have had deep probing case studies. We have had surveys. We have had different kinds of experiments, optimization studies, simulation studies. We have had games. And all these contribute with very, very different complementary input for our understanding of this complex challenge that we have dealt with. And without these different methods, we have not been able to have this rather maybe fragmented if you look at it very quickly, but I mean, it has increased our understanding of this issue, I would say. We have also had very different types of data. We have had qualitative data from interviews, study visits, being and out in the actual sites, looking with our helmets and everything. And we have had data coming from mobile phones, from vehicle movements, and from horses as well. And we have also have, I mean, all these different stakeholder perspectives. We have not focused on just contractors, just the logistics providers. We have had citizens, municipalities, suppliers. We really wanted to have the different perspectives captured here, which has been, I think, we have learned so much really during these 3 years. Okay, so we also had the various country perspective, which has also been important. So now we are finalizing this project. I want also to thank Rodrigue for managing this cool project. You have done it tremendously well. Thank you. And this day also. And we also, of course, have Caroline and Lisa who helped us out today. Thank you a lot. And we have had now Civic and Mimic, and we are now, it's not end, we have more to learn. So I guess we will stay tuned for the next project. It will pop up any year. Thank you.
Thank you, Kajsa. Thank you. And please, if I would just like to add as well, thank you, Daniel, for handling all the technical parts today. I really hope that you enjoyed this day. It's been very nice. We may disagree on many topics when you talk about construction logistics, but from closer point of view, we're happy that we're discussing it and that we keep on discussing it and do some research and demonstrate and so on. With that, we're very happy that you were with us today. So thank you all that has been online. We will send the presentation. It will be available on YouTube soon as well. And thank you all that are joining us here physically. For you, there will be some more snacks when you come out. And yeah, we will continue talking. So thank you so much for today and goodbye.